Start stream. Okay, hello. Should I be live right now? Hello. Stream. Oh, we are live. Hey, 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 hey. Okay, okay. Okay, I just need some. I need NCS songs. I'm so tired. For some reason. Dun 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 dun. Okay, oh my god. What is this? I need to wash this keyboard. Oh my god, wait, should I put it more high up? Yeah, I should get other thing. Should look better at this, I think. Yep. Let's see more. Okay, let's go. Need to learn. Impossible. A method of efficient. I don't know what they want us from here. Like Prince2 method, I get it. Should I know the 4 levels of management? I don't know. I'll just write it as a question. Oh my god. I have no idea what I can ask. I don't even understand what this word mean. Corporate or program management level? Project board level? What is a project board? Project manager level? Or just ask the best. Just ask ChatGPT, right? So this is like the corporate of program management is the biggest one, and the project board. What are the project board? It represents customers, users. So this is a manager. The board looks at the seniors, I don't know, directs, monitors the project. Monitors the project, and this is manages it every day and the delivery level. This is so hard for me because I have no idea what's happening here. No, 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 no. Okay, it is this, but I'll just copy paste it because I have no idea what's like what. I don't think we really need it, but okay. I don't get these things. Like, what does this mean? He didn't even explain this. I'm so mad. What are the themes here? Prince2 processes. Like, what do you mean? You have principles and you have themes. What are the methods of Prince2? I don't know, should we really ask her? Okay, you have to plan. Product definition. Project plan on different levels. What? You define the product and your project plans on different... I mean, you have to plan. It doesn't make any sense for me because we don't do that thing. Risks, change, quality, progress, organization. Okay. Need to organize, need to look at the project, change, quality, risk, business case, but like, I don't understand what that means. Just move on. Typical project documents. Okay, project definition document charter. Project just puts things in, it doesn't make any sense. What are some project documents? Project definition document charter. Project work plan. So you have a project definition. This is like whole semester you can go just. And what is this project definition document? So there's the project. Please sit down. What will we do? Project work plan. How are we going to do it? Project handbook. But what is the difference? Never mind, no idea. Quality assurance handbook. You need to quality assurance handbook. I don't understand these. I don't understand what you want here, like. Quality assurance handbook, wow. What do you mean quality assurance handbook? Like project handbook, quality assurance handbook? Where is the difference for the whole project, introducing a project? Like you can't see the difference, it doesn't mean anything. Can you just... It's so dumb. didn't even explain this. These don't even deserve to be flashcards. These don't even deserve to be flashcards. This one, yes, but this one doesn't deserve to be a flashcard at all. Well, no idea, he didn't even explain this, so it just doesn't make any sense to me, so we move on. Aspect and goals, what can be reached simultaneously? See also just a triangle theory, some stupid theory in management, doesn't make any sense. What is a triple constraint triangle in project management? In the modern corporate landscape, a project is typically bound or constrained by three elements which may be expressed in different ways. The triple constraint theory, also called it iron triangle. Iron triangle, why is it called iron for some project management? Defines the because maybe it's a boundary, right? And they call it an iron boundary. I don't know, I believe you call it iron, but let's move on. And how is this software engineering, for God's sake? Defines the three elements and their variation as follows: scope, time, and budget. Yes, budget and cost. Scope, schedule, what, and cost. Good, fast, cheap. What? You have a scope, so you have, are you doing the right thing? You have a time and you have a budget. So you have budget, time, and doing the thing. How much do you want to do? Not enough time fully superable. A project manager may need to move employees from a first project to a second, which affects either the scope of the first project, blah 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 blah. Concept quality sometimes introduces another factor in the project, as a fourth lag. What? The concept of quality sometimes introduces another factor in the project constraint as a fourth lag in what would be a project diamond. What? However, there are varying views on this, as quality is subjective. Does the quality of a less in-depth page suffer, or can it still be? What? But this is just like dumb. I can't anymore, this is so... We move on. And then it has a different picture. Resources, quality, risk. And then it has quality in the middle, it has quality here, like... What do you mean, bro? Like... What? How is it quality here and quality there? Aspects and goals. God knows what they want from us, so we move on. We move on. We remove flashcard from Ace because I don't wanna have even to do with flashcards. Control V. I hope it doesn't get this, it only gets this, I hope. Now we move on. Work pack, okay. Project leader sponsors. So sponsors have a strategic planning. Okay, they have resources, yes. Support business decision making, yes. Establish, approve success criteria. What does it mean by success? Yeah, it makes sense, but it does the whole planning. What are kinds of project leaders? This makes more sense. Project leaders. So you have sponsors, you have project manager, sponsors, resources, and planning, and this is execution. Stakeholder. Are stakeholders sponsors? Are our stakeholders sponsors? Are sponsors stakeholders? You see, in some cases, a stake. Right? Get over that. Oh my god. Okay, work package. What do you mean by work package? Work package. Like, what the name is this? I'm so mad at this. A related task connected with jointly. Can we just, you know what? These people have no brain at all who made the slides, or we are so far away with their mindset, it just doesn't make any sense. Work package, a hierarchically decomposed element of a project. What? What is an element of a project and it's a decomposed? Contains related tasks and activities with jointly responsible resource and cost. Characteristics, responsibility, assigned to a specific individual or a team. Clearly defined roles, responsibilities, resources, just the work package is just a small, like, work thing that you assign, I see. So what is a work package? So what small unit of work, which is what I got. Analyze. Analyze. What? Deliverable. I don't know what they mean by this, like. It just looks so abstract and doesn't make any sense at all, but okay. No idea. Maybe some super guy in YouTube can explain this to us. Let's see, let me...
Today let's talk about one of the most powerful charts available in Training Peaks, the Performance Management Chart, or the PMC. It all starts with training stress. Every workout you do is assigned a training stress score based on duration and how intense the workout was relative to your threshold. Here we see a red dot representing each day's workout for an entire season. The red dots at the bottom of the screen indicate that there were no workouts for that day. By taking an exponentially weighted average of that stress from the past 7 days, we're able to calculate what we call your acute training load, or an estimate of your fatigue accounting for the workouts you have done in about the last 2 weeks. Here you can see on days with a workout with a high training stress score,
Good afternoon, everyone. Welcome to the webinar. Hopefully you guys can both hear me and see my screen. I see people saying audio and video. Okay, awesome. All right, let me just delete a couple of those. Good afternoon. Hello, hello, hello. Okay, looks like another full crowd today. Hopefully everybody gets a seat in a spot. I always delay a minute or two, but let's jump right in and get rolling. I'm hoping to keep today's webinar a little bit shorter, but we'll see how that goes. Today's webinar is on the Performance Manager Chart. My name is Tim Cusick, and I'm the Training Peaks WOKO product leader. We're really going to go. I'd like everybody to feel free to area that says today's webinar, when I drill down webinars into such a specific topic, it really becomes a challenge to execute it because you're really talking about the PMC, but the duration and intensity of each workout. Very simply, that's what it is. You're basically taking in one form or another. You work out on any given day. That workout is applied a training stress score. And then if we want to use that training stress score to understand performance management over time through a group of different aspects, right? Really 3 core ones, which I kind of think is 4 core ones right now, but we'll get into that. But 3 core elements in the performance management chart. In its simplest view, this is what it looks like in WKO. Joe Ryder here is acting as our, oh, excuse me. I didn't mean to cough on you guys. We're having our first day of spring, or day or two of spring here, so there's enough pollen in the air to choke me. So here's our very...
If only this doesn't look very... Can I... this doesn't make much sense to me, but okay. Oh, no. You just... actual cost of work. Let's ask that all. Let's see, WP. No, can you stop? BCWP and BCWS. Earned value management, okay. Actual cost incurred for the work performed on the project. Okay. So this is how much we have actually used. Actual cost of work, yes. And we have budget cost of work performed, yes. A value of a completed work expressed in terms of a budget assigned to the work. What? The value of a completed... what do you mean expressed, right? Expressed. Ah, okay, how do you calculate it? Mathematics, for God's sake, mathematics is great. Percentage of completion multiplied by total budget. So it is percentage of completion multiplied by... so we have like, suppose 7% times the total budget. Say 1 million. So you're saying tells you tells you what they think it would cost at this moment. BCWP, right? How much they think this would cost at this moment. And this is what is the actual cost. And this tells you how much work, with deviation of the work. So if you see the money spent, you see the deviation. But you have how much percentage is covered. How much is the cost variance? How much the cost? Yeah, it just tells you how much the cost is changing from the one we supposed it was. The green one is what they expect it to be. The red one is what they got, and the green one. Is this the same? Oh, they're saying at this time we plan to be completed this much. So the difference between this is a difference on time. Oh, so that... oh. Why do they give such weird name? So the green one, budgeted cost of work. It means at this time, this is how much the work they thought they will get. Why do they complicate it for no reason at all? Like they don't know math or something. Like, what are they doing? I don't get them. Like, performance management chart. Okay, so you have ACWP, the work performed, actual work, the cost of the actual work, actual work at that moment, budgeted cost for work performed. The cost they thought it would be. The actual of the work. Right, so cost planned of the work at that moment, and you have BCWS. BCWS. the cost planned in last time planned. That moment. This tells you how far you are from the budget, and this tells you how far you are from the time. I mean, you can just... This is so dumb. Like, I hate every bit of it. Let's move on. It's so like... Okay, now let's try to understand the chart they just put in a slide, and then... Oh my god, this professor sometimes. By current reference point. What? Estimation by current reference point. And where is the reference point? And this tells you how far off. Yes, this tells you. I see, I get it. But it's so dumb. Like, you just put 20 things in a slide and no one will understand this. SVT, ACWP, CV, minus 200, 400. Then you have... So this tells you the budget. And what is CV? You just put, what is CV here? What is SV? What is CV? What is CV at T? So this is cost of 1000. We have the difference in this point, so it just says, at this point is 500 it says, and the difference is, yeah, minus 200 is the difference. Right, and then we have from here to here saying how late you are. This SV is this triangle here. Estimated time of completion. Yeah, this is the estimated time, but how do you just even draw this? This is minus 200 here. Ah, so they give minus 200 here. Oh, so, they get here, you get this, and you get the cost, I see. So this thing is just here, because this tells you how much with time you differ, so we just put it here, and this tells you how much the money differ, this kind of thing right here. So you just put it here, and you have the estimated time of completion. Oh my god, this is so weird, like, because you don't explain exactly what these functions mean, and you're like, what? This is the original time and this is the other time. So this is this thing right here, because it tells you how far off you're with time, and this thing is how far off you're with budget, and it's here. Estimation by current performance. Estimation by current reference points. I get this. Estimation by current performance. Also, you say it's minus 200 for this much, so it's gonna be minus 200 again. It's minus 500. How do you measure it? You're late 400. Cost. How do you find the cost performance index at the first place? It's 0.66. Yeah, it's the same delay. With a delay, so you encounter this, the CPI, which I don't know where I calculated the CPI. Cost performance index, somehow you calculate it, doesn't tell you. Find this, how much is the difference, somehow you divide it by that. And you get this, schedule performance index, cost performance index, schedule performance index. Okay, and then you divide by their multiplication. 1000 minus 400, and when y minus 400, that because the difference here is 400. God knows. So they also want us to know a chart, they want us to know prince methods, you have themes, principles. Oh, what are the main ones? Like, what are, let me just finish, what are the main parts of Prince to method? You have principles, and then on top of that you have themes. It doesn't make any sense to me, but let's move on. Themes, and you have processes. It's just something you remember in your head, like you're not. Like it doesn't. Where is the logical connection here? I wrote this wrong. We move on. I don't like this. And somehow you calculate it using, and then you have 600. This is not even. What's this? How? Where do you what? Do you do a division first, or do you add up first? Like, what do you mean by this? Why did you write it? Dr. Balakatelan project. I hope I never. She probably meant something completely else, and this guy didn't wanna. No, no one has no, like. What the hell? I know what's happening here. Do we have views? Chat? Do I have chat? Or I don't have chat at all. Chat? Did anyone write? I hope no one wrote. Oh, koyebe már. Spotted. Like, I don't know. Maybe takam cét and stuff. YouTube. There's lives. Yeah, let me get this chat. Pop up chat. Oh my god, how does this sound? Can I? Pop up chat. Can I? No. This. Oh, here. Yeah, but I don't get this, like how they calculate. They don't even tell you exactly how they calculate it, so it's so annoying. It never makes sense. Because like it doesn't make any sense at all how they calculate this. Like this one math makes sense, but this other things do not make any sense. Like this is, I don't know what they want from us here. 600. What? Planned cost of the remaining one. This is just 400, and this is like 200 in here because you lost 200 here. And then somehow you have a cost performance index that I don't know how you calculate from this chart, but somehow you calculated it, and then you multiplied that here for no reason at all with 0.66, and I'm like 1500. What do you mean? What are the indexes in performance management chart? CPI, cost performance performance index, and then you have the other one, CPI estimation. That's just estimation. Schedule. I have an idea, index. I have an idea though, because the idea is that so they saw that you had so what is 600 over 400 or 400 over 600? So we have yeah, but it's not that, right? The difference is 200 between them, or you can measure for that time. You can measure for that time how much they're changing, right? How much is the slope changing here? And that's what the CPI index is. It doesn't tell you how it is calculated, but I get the point. This is how much it differs here. So let's suppose that here it will differ more and more and more. So it will keep differing. That's the point of this. So we differ this much, and then this time we differ this much. So, and somehow we put the same amount here, and this makes sense. But why 600 plus that? And here there is no 600. I don't know. So we just leave it here now because it doesn't make any sense. But we move on. Can I like, or I cannot like comments here? Move on. Just don't get this at all. Let's go to the next one. Let's just put them on 90 because no one understands this. I need. Please, hello. Oh, I didn't put that flashcard. Okay, I know agile development methods is gonna be easier. So let's put the new. No, I don't need a new folder. Delete. I need the new. Agile. Agile development methods. I need this. No. So we have agile development methods, okay. Now we start asking questions. So at the end of the lecture, students are... Wait, what was this? What should I have understood here? What does he want to understand here? Understand the basic concept of project management. I don't know, you have some Prince2 methods, you have some boards and some things I don't understand at all. Then you have some triangles that don't make any possible sense mathematically. Don't, like, you have quality here and quality inside, like what are you doing? It doesn't. People are in a project, they just like philosophy. This is not even straight science, it's just philosophy trying to understand. I love business guys, they don't make any sense. Oh my god. And then understand the basic concept of project cost and their estimation. Well, I have some concepts, I guess. Yeah, basic, okay. Yes, I know the use cases. They're used everywhere. I think it's a software basic. Oh, yeah. Where's the music? Wait, I stopped the music. Na 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 na. Na 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 na. Okay, so processes and projects. We have methods, measurement and analysis, and project management, and methods. So you have a Kanban method, that's Kanban, they're all subdefined. Okay, let's go. Reminder, basic principle of agile. Yeah, individuals and communication, predefined processes. This is better, the agile working software. No, working software is better. Real cooperation with the customer, yes. Adapting changes, following a plan, this is greater. Yeah, short iterative steps. Small but multidisciplinary trams. Oh my god, I don't know what it means, but I get the point. You have Kanban and you have Scrum. No, Kanban origin, production technology, meaning signboard. No. Toyota production. Okay, we don't care where it was discovered, but okay, motivation, too many parts, semi-finished product, too many product phases. To produce only things that are needed, just in time. That's Kanban. Many applications in your production. Water. What? Oh, okay. I can just ask what are the Kanban general rules, but it makes no fucking sense, right? I can. Well, this is what I should ask. Like, in the Kanban method, do you no. The fun till I downfall, my love, if you feel like I do right now. And then how do you manage the resources? No. No. J. Until I downfall, my love, if you feel like I do right now, make it. Well, I don't understand what you mean rationalize the process. Make it rational? What? Na 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 na. But you never do. Rationalizing a process, definition streaming or optimizing a process at greater efficiency, streamlining or optimizing. It's just optimizing, rationalize. Optimize. Eyes in the sky, they seem fall into the night. Let my hand defy so goose. Something running through the life in new product. So use cases for developing a new product or service plus product support. Yes, supporting an existing product, developing a new product. All possible use cases are here. Like you can develop a product, you can support a product for further use, and you can develop a completely new product. What? What do you mean? It's just... Oh my god, Kanban board example, yeah. No. So you have states, you have life cycle, so you have life, you have life cycle, state, and you have work item. Na. What are life cycles in Kanban? Look, there isn't a life cycle. I mean, a life cycle is from the start to the finish of a item, right? Plus 5 cycles. And you have swim lanes. You have swim lanes. Swim lane, which is same as project. Nice. Yeah, for each category. Yeah, okay. So you have Kanban in GitHub, let's go. Okay, I know, but I want this. I want to hear this. Like this a ton. Oh, I'm raced. Oh my god, I'm used to this. Will I get banned from YouTube? Probably. From those songs. Let's see what to sing. Nah, do I care? How is my stream going? Let's see. Will I get banned from YouTube? Probably. From those songs. Let's see what. Oh, hello. Okay, it's working. Nice, I guess. Okay, let's go. Further tools. Checklist, partition of work, item integration with output considered for testing with teamwork software. Slack. Integration tools. Ah, so you have testing for integration, I see. Work items per list, yeah. And you have like examples. Miro has one, Monday, Jira, Trello. Okay, for the checklist, partition of a work item, a checklist. Yeah, you need to partition work items and so on. And it's just Kanban is easy, I guess. Some examples of Kanban, will they ask us? We need to limit the length of integration. Yeah, checklist, partition of, yeah. So you have, a checklist and a work item, and you have a checklist. You can have integration and messages. Testing, and messages. Okay. Let's do it like this. Give some examples. Give some Kanban examples. Trello, Jira, Miro, GitHub, I guess. MS Project has one, but I don't care. So move on. Easy Scrum method. Framework for Agile. Switzerland. Let's go. Schwaber. Basic philosophy. Transparency. Adaption of. I don't like when they use these keywords because it doesn't make any. What do you mean? What is a transparency in a project? Everyone knows. Yes, everyone knows everything. Adaptation. Tactics may be changed. Okay. Observation. Consider following the results of a work. So everyone knows everything, so you're transparent, you have adaptation to everything, so you have that. You have an observation for everything. What's happening? Does it care about the philosophy? Main elements and functions. Well, we may never know what they want from us, so let's move on. So, what is? I hope they... adaptation of the Pigs. I don't understand this metaphor, pigs and chickens. It doesn't make any sense. Management is stakeholder, customers, user, technical. Management, yeah, because they don't have direct impact. But manages is a management, it manages everything. How are they stakeholders? So you have stake and participants but these guys manage like all the things are like higher level managers, I guess. Let's see. Oh, I love this, that I can just like...
Scrumguides.org. Scrum Guides. 2330 minutes. This HTML version of the Scrum Guide is a direct port of the November 2020 version available as a PDF here. Purpose of the Scrum Guide. We developed Scrum in the early 1990s. We wrote the first version of the Scrum Guide in 2010 to help people worldwide understand Scrum. We have evolved the guide since then through small, functional updates. Together, we stand behind it. The Scrum Guide contains the definition of Scrum. Each element of the framework serves a specific purpose that is essential to the overall value and results realized with Scrum. Changing the core design or ideas of Scrum, leaving out elements, or not following the rules of Scrum, covers up problems and limits the benefits of Scrum, potentially even rendering it useless. We follow the growing use of Scrum within an ever-growing complex world. We are humbled to see Scrum being adopted in many domains holding essentially complex work, beyond software product development where Scrum has its roots. As Scrum's use spreads, developers, researchers, analysts, scientists, and other specialists do the work. We use the word developers in Scrum not to exclude, but to simplify. If you get value from Scrum, consider yourself included. As Scrum is being used, patterns, processes, and insights that fit the Scrum framework as described in this document may be found, applied, and devised. Their description is beyond the purpose of the Scrum Guide because they are context-sensitive and differ widely between Scrum uses. Such tactics for using within the Scrum framework vary widely and are described elsewhere. Scrum definition. Scrum is a lightweight framework that helps people, teams, and organizations generate value through adaptive solutions for complex problems. In a nutshell, Scrum requires a Scrum Master to foster an environment where a product owner orders the work for a complex problem into a product backlog. The Scrum team turns a selection of the work into an increment of value during a sprint. The Scrum team and its stakeholders inspect the results and adjust for the next sprint. Repeat. Scrum is simple. Try it as is and determine if its philosophy, theory, and structure help to achieve goals and create value. The Scrum framework is purposefully incomplete, only defining the parts required to implement Scrum theory. Scrum is built upon by the collective intelligence of the people using it. Rather than provide people with detailed instructions, the rules of Scrum guide their relationships and interactions. Various processes, techniques, and methods can be employed within the framework. Scrum wraps around existing practices or renders them unnecessary. Scrum makes visible the relative efficacy of current management, environment, and work techniques, so that improvements can be made. Scrum theory. Scrum is founded on empiricism and lean thinking. Empiricism asserts that knowledge comes from experience and making decisions based on what is observed. Lean thinking reduces waste and focuses on the essentials. Scrum employs an iterative, incremental approach to optimize predictability and to control risk. Scrum engages groups of people who collectively have all the skills and expertise to do the work and share or acquire such skills as needed. Scrum combines 4 formal events for inspection and adaptation within a containing event, the sprint. These events work because they implement the empirical Scrum pillars of transparency, inspection, and adaptation. Transparency. The emergent process and work must be visible to those performing the work as well as those receiving the work. With Scrum, important decisions are based on the perceived state of its 3 formal artifacts. Artifacts that have low transparency can lead to decisions that diminish value and increase risk. Transparency enables inspection. Inspection without transparency is misleading and wasteful. Inspection. The Scrum artifacts and the progress toward agreed goals must be inspected frequently and diligently to detect potentially undesirable variances or problems. To help with inspection, Scrum provides cadence in the form of its 5 events. Inspection enables adaptation. Inspection without adaptation is considered pointless. Scrum events are designed to provoke change. Adaptation. If any aspects of a process deviate outside acceptable limits or if the resulting product is unacceptable, the process being applied or the materials being produced must be adjusted. The adjustment must be made as soon as possible to minimize further deviation. Adaptation becomes more difficult when the people involved are not empowered or self-managing. A Scrum team is expected to adapt the moment it learns anything new through inspection. Scrum values. Successful use of Scrum depends on people becoming more proficient in living 5 values. Commitment, focus, openness, respect, and courage. The Scrum team commits to achieving its goals and to supporting each other. Their primary focus is on the work of the sprint to make the best possible progress toward these goals. The Scrum team and its stakeholders are open about the work and the challenges. Scrum team members respect each other to be capable, independent people, and are respected as such by the people with whom they work. The Scrum team members have the courage to do the right thing, to work on tough problems. These values give direction to the Scrum team with regard to their work, actions, and behavior. The decisions that are made, the steps taken, and the way Scrum is used should reinforce these values, not diminish or undermine them. The Scrum team members learn and explore the values as they work with the Scrum events and artifacts. When these values are embodied by the Scrum team and the people they work with, the empirical Scrum pillars of transparency, inspection, and adaptation come to life, building trust. Scrum team. The fundamental unit of Scrum is a small team of people, a Scrum team. The Scrum team consists of 1 Scrum Master, 1 product owner, and developers. Within a Scrum team, there are no sub-teams or hierarchies. It is a cohesive unit of professionals focused on one objective at a time, the product goal. Scrum teams are cross-functional, meaning the members have all the skills necessary to create value each sprint. They are also self-managing, meaning they internally decide who does what, when, and how. The Scrum team is small enough to remain nimble and large enough to complete significant work within a sprint, typically 10 or fewer people. In general, we have found that smaller teams communicate better and are more productive. If Scrum teams become too large, they should consider reorganizing into multiple cohesive Scrum teams, each focused on the same product. Therefore, they should share the same product goal, product backlog, and product owner. The Scrum team is responsible for all product-related activities from stakeholder collaboration, verification, maintenance, operation, experimentation, research, and development, and anything else that might be required. They are structured and empowered by the organization to manage their own work. Working in sprints at a sustainable pace improves the Scrum team's focus and consistency. The entire Scrum team is accountable for creating a valuable, useful increment every sprint. Scrum defines 3 specific accountabilities within the Scrum team: the developers, the product owner, and the Scrum Master. Developers. Developers are the people in the Scrum team that are committed to creating any aspect of a usable increment each sprint. The specific skills needed by the developers are often broad and will vary with the domain of work. However, the developers are always accountable for creating a plan for the sprint backlog, instilling quality by adhering to a definition of done, adapting their plan each day toward the sprint goal, and holding each other accountable as professionals. Product owner. The product owner is accountable for maximizing the value of the product resulting from the work of the Scrum team. How this is done may vary widely across organizations, Scrum teams, and individuals. The product owner is also accountable for effective product backlog management, which includes developing and explicitly communicating the product goal, creating and clearly communicating product backlog items, ordering product backlog items, and ensuring that the product backlog is transparent, visible, and understood. The product owner may do the above work or may delegate the responsibility to others. Regardless, the product owner remains accountable. For product owners to succeed, the entire organization must respect their decisions. These decisions are visible in the content and ordering of the product backlog, and through the inspectable increment at the sprint review. The product owner is one person, not a committee. The product owner may represent the needs of many stakeholders in the product backlog. Those wanting to change the product backlog can do so by trying to convince the product owner. Scrum Master. The Scrum Master is accountable for establishing Scrum as defined in the Scrum Guide. They do this by helping everyone understand Scrum theory and practice, both within the Scrum team and the organization. The Scrum Master is accountable for the Scrum team's effectiveness. They do this by enabling the Scrum team to improve its practices within the Scrum framework. Scrum Masters are true leaders who serve the Scrum team and the larger organization. The Scrum Master serves the Scrum team in several ways, including coaching the team members in self-management and cross-functionality, helping the Scrum team focus on creating high-value increments that meet the definition of done, causing the removal of impediments to the Scrum team's progress, and ensuring that all Scrum events take place and are positive, productive, and kept within the time box. The Scrum Master serves the product owner in several ways, including helping find techniques for effective product goal definition and product backlog management, helping the Scrum team understand the need for clear and concise product backlog items, helping establish empirical product planning for a complex environment, and facilitating stakeholder collaboration as requested or needed. The Scrum Master serves the organization in several ways, including leading, training, and coaching the organization in its Scrum adoption, planning and advising Scrum implementations within the organization, helping employees and stakeholders understand and enact an empirical approach for complex work, and removing barriers between stakeholders and Scrum teams. Scrum
This is such a large thing, oh my god. This guy is insane, like look at this Scrum guidance. Old Scrum guide, I guess. So to observe what's happening and what is changing, you need to adapt to those changes. You have that transparency so everyone knows. That's I see. It's called they call it observation, but here they call it not observation. Inspection. I translated from Hungarian, was and then you have what roles does Scrum include? What roles does Scrum include? Okay, we have participants, which are the product owner, Scrum Master, and we have dev team, development team, and we have a stakeholders. How do you write managers there? I don't understand what these guys are thinking, like stakeholders, and I write management. But product owner and Scrum Master are management, like how do they not? Yeah, the Scrum Master is a guy who tells the Scrum Master does that. It enforces the Scrum theory and the Scrum ideas. It enforces them. It makes meeting things. So it enforces the social thing. The product owner takes the product, it decomposes into. It takes the product and it decides what we should do, the goals and the things. Customer service. Somehow it's management. This is called management. Steps. What are the steps of Scrum? What are the steps of Scrum? This is very important, I guess. Okay, do some push-ups. You know, I love doing push-ups. Let's go 20 push-ups. I don't know. Let's move on. Sometimes I just wonder people who watch this like what are the steps of the Scrum method? I don't know. The team and the stakeholders discuss the results. I think it starts from here. A project PO. It all depends. Yeah, a product owner. Product backlog item. PO. PO that decompose. So I get the backlog items. So I get the backlog item. Cool. So you have PO that decompose. And here you put the project. So you're taking the project and the PO decompose it and you get the backlog items. And then we have also we have dev team dot. So we have start sprint. So we have a dev team and a dev team. So it selects items collectively. Select. So you have backlog items. You select selected part of it. So you have items. Na 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 na. Hello. Okay, dev team select items. So you have dev team, start sprint, dev team sprint. Scrum Master. Not really. Yeah, stakeholders dot iterate. No. Review, discuss. Or review. Discuss the results. It returns. So I turn a change project, and then project is equal to so it's just, and you have while so you have a new project, and so you have a project, you have product owner. Dev team. They get a new dev team. Yeah, Scrum Master. Doesn't matter. So it creates the backlog items, it creates a product backlog items, the devs Texas items, and then it's autonomous items, and then run the sprint. So the sprint is finished, you get the results, and then the results are, yeah. What does product owner do? Strategy roadmap. Same thing. Financial cost forecasting. Forecast cost. Performance. Let's go. Na na nee na nee na nee na nee, not miles away. Da. Dun, da, na 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 na. Educational, keeping team focused, organizing events. So how can a project goal be efficient? That's my question. Oh my god, it's a bad one. How can a project goal be efficient? Clear and specific, measurable outcomes, relevant. I see a good project goal. I see. Na 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 na. Exporting the one. No. It's not called a project team. It's called a project team. Participants, and that's a project team. Ah, yeah, the team of a project. You can say it. So you have a project team. A complete project team. Squad. Single. Product owner, Scrum Master, Dev, and Dev team. Chapter. What is a chapter? Well, a chapter is people with the same people or employees, or what are those people? Or people. They're not they are people, but they are like roles. Yeah, they're roles, but they're not called people. It's called people, I guess. Employees. What is a tribe? Squads. Oh, I'm tired there. Stand-up meetings. What are the Scrum events? What are the Scrum events? So first you plan. Sprint backlog, backlog, product backlog, and sprint backlog.
Masashi Sensei.
So you need to plan the sprint. What is the goal? What is the plan? And what is the product backlog selected? Makes sense. I have a daily scrum. Daily scrum, and then you have sprint review. No. No. And then you have sprint retrospective. I don't understand, but it's okay. So we have sprint retrospective. I don't know. It's a plan ways to increase quality and expect the outcome. Plan next. It's just product backlog. Yes. Which backlog requirements? You have two backlogs. So you have a normal review and to what to change, retrospective, how to refine. Inspect and plan. Refine. Retrospective is how to refine. Sprint backlog. Sprint backlog. No. What are the possible backlogs in Scrum? Sprint backlog. So you have sprint backlog. Sprint backlog, and you have product backlog. So you have Scrum events and you have Scrum processes. No. Story points. Oh, definition of done. Oh. I'm mad. Like, this makes me so mad. Scrum is so like, I wanna do math only, let me do real programming. This is crap. This is no. Okay. Product owner. PO. Okay. I want to learn more. Can I remove it? Yes, X. Thank you. I cannot remove it. Ah, very fun. Top chat, live chat. I don't know, live chat. Same thing. Scrum, now we have Scrum processes. So you have a new project, you have a product backlog, and a backlog for 4 hours. And you have a planning for 4 hours. Sprint planning. So, yeah. Explain the whole Scrum process. So you have a new project, you have a product backlog, you have a sprint planning. So you plan for 4 hours for the backlog and planning for the sprint. Well, I mean 8 hours to do it all, it's not bad. And the sprint, you do 30 days, daily meeting every 50 minutes, do work, update hours remaining, and you just iterate until it's finished. Then you need to sprint review, and then you deploy, no, project done, yes, deploy sprint, project done, no, yes, stop, yes. But if you do not deploy, then project is not done. What? No, go to new project. I mean, it's okay. Elementary functions? Aha. Expected balance, yes. Planning poker. You do need to determine the complexity, the risk, the previous similar experiences. I know what this means. Oh. I see. What are how do you measure how hard are the work item method do Scrum complexity and risk. How hard? Complexity and risk. That's what. And risk. Scrum. We use story points. What kind of measuring? Use Fibonacci. Approximate Fibonacci. Na 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 no 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 ta ta na 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 na. Burn up chart. Oh, I told you though, backlogs. Not changing us Windows already. You can refine the product backlog. I don't know, burn up chart. What? Oh, so you have a task and you have a statuses for each task. How much is done? And then how much is done? And why do you have it from 80? Oh, how much do you burn up? I see. Burn down is the other way, yeah. How much of the work is burned? How much of the story points are burned up, right? Yeah, we were completed over time. That's the burn up chart. What is the burn up or burn down chart? How much? Yeah, so this is our practical idea. Okay. User story. Backlog. Okay. Na 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 na. Acceptance test. Right and responsibility. Accepting the sprint. So every test is executed, every code is reviewed, test coverage, acceptance of requirements are fulfilled. Refactoring is complete, completion of build changes. Definition of done. Accepts. How do you write accepts? Accepts. Anyways. Ta 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 na 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 na. Agile Inception deck? Starting a project. How do you start a project? You just start the project? Agile Inception deck. I don't understand this. Inception deck. Na 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 na. Tan 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 na 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 na. They didn't even give us access. Da na 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 na. Project Kifcock, yeah, how to start a project. Oh my god, it's snowing. Oh, this is cool, Miro. Oh my, I love it. Oh, this animation is so cool in the background. Does it follow a straight line? Let's see. Yeah, it follows, yeah, it's not hard to make. This is pretty easy to make. Dun, 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 dun. I love it. Dun, 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 dun. Agile Inception deck. So we have why are we here, not list, what not shouldn't be done, what makes us sleep, elevator page, get to know your neighbors, estimated product boss, what can we add, what I mean, Agile Inception deck. Let's see what. What does it have to say? Collaborative workshop used to the beginning of Agile project to align the team, stakeholder, and product vision. Product vision, a high-level description of product backlog, initial persona, role, scope, boundaries. Okay, I see. When you start a project, you have and it's called a DAG because you need to ask these questions. Ready out, let it. Oh, it's called answer, right? Let it out, let it out. Oh my god, so many. It takes 1 hour and I have 16 of them. I have 14 left. Yeah. Scrum meet task, yeah. All these songs are so good. Crazy. Dun, 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 na, 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 na. This camera should focus. Or should I clean it maybe? Okay, now it's clean. Ah. Dun, na, na. I should clean this. Don't look at. Oh my god, it looks so disgusting. Ah. No. Well, it's better than it was, so. Da-na-na-na-na-na. What makes agility different? The general approach is not about methods or integrated to oppose additional functions. Yeah, it's about formal frameworks. 10 minutes, 5 meters. What? 5 meters? I don't know what to say. Organization of work is greater than process plus ceremonies. Yes. Communication among teams without organization. Yes. You don't need to write everything. You don't need to do 10,000 million paperwork for a small code you need to write. Large-scale agile projects. Example: the development teams led by their Scrum Master, and example, but development teams led by their Scrum Master, development team, because each Scrum Master is for one team. Their specific Scrum Master, yeah. So each team has one Scrum Master, and the product owner work on the common product backlog of a task to be performed and features to be implemented. Yes. User stories, okay. CI/CD pipeline, yeah. Continuous integration, continuous deployment pipeline. Management, product backlog, sprint backlog. Yeah, so you got management, you have a product backlog, a sprint backlog, you have a build, dependency management, CI pipelines, continuous integration pipelines, starting code analysis, test, unit test, integration test, CI pipelines, deploy, CD pipelines, infrastructure, configuration management, infrastructure management, container, and binary code repository. Run, containers, orchestration, monitoring, yes, deploy, test, deploy. Right. Yes. DevOps. So plan, create, verify, package, release. Yeah. What? Configure? Is it configure? Observe, I think. It can be configure, monitor. Yeah. Sometimes I don't understand what they mean, but okay. Example: required agile methods. Required agile method: preparatory study, vision, business requirement, user stories. Okay. Product backlog, yes. Sprint planning, sprint backlog, sprint review, sprint retrospective. What can we change? Not finished. Finished, done, working for shipping. Okay, nice. A PM tool, PM Square Agile Guide. U specification, PM Square Agile Guide. Oh my god, this management U things are just... it hurts my brain, but we move on. A project management methodology developed by European Commission enabling and supporting the use of agile practices in any type of project or work activity, any type, not only the software. Okay, technical annex, contractor's office, initiating, quality management plan, project handbook, project work plan, initial plan, project status reports, follow-up meetings, project end report. I don't know what they're doing. Honestly, no idea what's happening. Initiating. Technical annex. I don't know what is this. Contractor's office. Contractor's offer. Okay. Quality management plan. Project handbook. Project work plan. Quality management plan. Yeah, we had this quality management plan, project handbook, project work plan, project status reports, follow-up meetings, report and report. Project status reports, follow-up meetings, project end report. Scaled agile framework. What is the agile guide from the EU, European Union, PM squared? Scaled agile? What do you mean scaled agile framework? Enterprise solution delivery, okay. Lean portfolio management. Okay, business agility, organizational agility, continuous learning culture, corporate level agile, considerable overhead. Bro, I don't understand this, it's so far off. You just put a picture here and you're supposed to. Customer centricity, lean agile leadership, team and technical agility, agile product delivery, team and technical agility, lean agile leadership, continuous learning culture, organizational agility, lean portfolio management. No idea. We move on. Oh, this is so good. This picture I love because it tells you a lot. So you have, let's start. Extreme programming. So your program, sustainable pace, pair programming, sign up, daily meeting, iterations, velocity, frequent releases, collective ownership, continuous integration, simple design, refactoring, to do. I know TDD. Something. Test driven, yeah, test. User stories, yes. Continuous integration, yes. Continuous deployment, yes. Automated build, yes. Version control, yes. Incremental deployment. Team. Incremental deployment. Fundamentals. Invest. 3 C's. User stories. Backlog. Definition of done. Kanban board. Task board. Burnout chart. Iterations. Pair programming. Yeah. User story template given when. Then acceptance test. Two is down. Refactoring version control. All the others I know. Test driven deployment. Okay. I mean, this is good. Agile methods are also done. Move on. I just log in, please log in. Na 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 na. Software life cycles. Download. Lifecycle models. Well, what was for 15? Oh, no, this is okay, nice. And this was understand basic principles of yes, Scrum roles and define their and steps defined by Scrums. Yes, nice, I understand those. Understand the goals of the software lifecycle models, and there are goals of the software lifecycle models. What are the goals? At the end of the lecture to be able, yes, identify the basic lifecycle models. What are the goals of lifecycle? Why do we need lifecycle models? I see. Agile development method. Okay. Then. I don't have a lot of, I have 14 left. No, we can do it, no problem. I need something to eat right now. I'm gonna eat that apple. Cut some slices of this. Oh well. Well, I'll be back in a bit, I guess. Can't stay here. Ah. Nah, it's funny. I'm cutting some. Let's see. You want to see how I cut? This has become weird. Life. This has become such a. Oh my god. Oh wait a second. Oh, you can see me. Hello. Yeah, this is fun. Today I'm gonna show you how you cut. This is because it's so funny. Oh my god, oh this looks good, not gonna lie. Does it have a... I think it has yeah, it has a thing I need to remove. But I hate removing it here though. Ay ay. Dun 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 dun. Okay, nice. I hate that. Yeah, this actually need to be. Throw it in the trash can. Not bad, not bad. Let's a bit of this. It's a bit of bread. Same. This. Ah, insane, brother. Insane food. And a bit of bread. I have some tomatoes too, but I don't want to. It's just so funny. I love this. I love this food. Really good. Really good. Oh my god. I hate it when when I open the bread and it's like everything just bread now. Bread. Well, another day to let's okay. I need to maybe I need to take to cut this thing better. I don't have time right now. Because my knife is just weak right now. I need to cut it better. Filet mignon. I like the cube shape of this a lot. Like yeah, I need to cut my knife. I have to cut my knife sharper. Don't judge me. Best stream ever. Not gonna lie. W stream. I like it when I cut it like this. It's like small pieces. Oh god, that salted tremendous. Okay, the force I'm putting into this. It's a bit too much, I think. But like, don't make me get the stone and make you sharper, right? It's funny how small things can make you happy. Like this insane. You see this? What are you? Oh, you have this. I see. But wait, here. You know what I need? I need some black fucking tea. You know what? Let me get some black tea, brother. If someone is watching this right now, it would be so funny. Imagine someone joins and just watches this. It's like, what is this guy? He's studying 100%. I'm eating. I'm refueling for my studies. No, oh my, I'm brain dead. Okay, let's go. I did 2 hours of streaming. Some black teas. Some black tea. Insane food. Dun 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 dun. Ah, the black tea. Did I make it? Oh my god, I need to clean it up now. Let's see, where is it? Where's the camera? Oh, it's here. Yeah. Happy New Year, I don't know. Happy Christmas. Don't say Happy Christmas, dude. Oh, this tastes so good. This is insane. Like, even if you cook me a 5-star meal right now, I wouldn't care as much as like the taste I'm getting right now. Like, it's like small things put together. Software, you want to hear me? Yeah. Yeah, sometimes I don't know. Bum, 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 bum. Software lifecycle models. What are software lifecycle models? It's just, I don't know, learning outcomes at the end of the lecture. Understand the goals of a software lifecycle. What are the software lifecycle models? So what are the specification of a software production? What are the specificities? Specificities. What is that word? These guys just use fancy words. I love mathematicians, not gonna lie. What are the specificities of software? Rep. Easy production. Yeah, what are the specific things about software from other systems? Yeah, I don't have physical constraints, I have logical constraints. Well, there is also some physical constraints, isn't there? Like with space and so on, there's a physical constraint, it's physical space. But yeah, we can say logical more. Easier reproduction, easy reproduction, true. Accuracy of false. How much false constant, how much consistent. So there will be false, but how much consistent it is. Easy rewrite, difficult modification, easy rewrite, yeah. And then we have some methods. vModel, Scrum, DevOps. Yeah, Scrum, I know Scrum, and DevOps, I know DevOps, and then vModel. vModel is pretty nice. But vModel is like for critical systems. Scrum is for agile, not just everyday things. Like small software and so on. Management, business management. How to manage a business. It's very hard because you don't even have a business to start, so when you talk about business management. And I'm like an engineer, like I like coding more. And here I'm just doing management. I have 0 drop frames. Let's go. Let's go. In 2 hours. It is what it is. What is love? Baby, don't hurt me. Oh, this is so good. This is tasting so good right now. It's insane. Like, oh my god. I'm Gordon Ramsay. I should call the stream Eat Food with Me, not gonna lie. Like
tea is oh, oh my god. Black tea is amazing, but when it's hot, oh no. No, 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 no. Probably I sound very bad right now because my mic is the other way around. But who cares? Well, let's put it to where it should be. What is love? Stop doing this thing, should I? Okay, now. Or how do I. Here. And then this is here. Hello. I'm eating, so don't mind me. I'm just eating. To make a good software. There is only one. This picture. I wanna. Can I? Concept of requirements. Concept of operation, requirements plan, risk analysis, prototype 1, requirements, verification, validation, deployment plan. What? No idea what this picture means, but we go on. What are the specificities of software engineering? Should I put some YouTube or something? I don't know, I'm eating. Let's see what YouTube has. It showed a $15 pro Valorant tournament. Can't really imagine. Well, I guess it's just you wait for me, so I just shouldn't put others' contents, I guess. Should I? Okay, we move on. So I'm just. Or I don't watch. I move on. I am a changed man. It's a joke. Can I go? Okay.
10,000 lines of code for airplane. Now it's too much lines of code for airplane. Oh, nowadays a critical system consists of up to 70 to 80% software. Each software greater than 1 million. Average program makes 10 to 12 errors in each 10,000 lines of code. So 10 in 10,000, that's like better thinking. No, 10 in 10,000? No. No, I mean 10 in 100. 10 in 1000, I mean in 1010 errors. I'm average program. I'm a bad program. This is similar to reflection. Processes of development and what does understand the goals of lifecycle models. Plan what you need to do. Let's say you have a life cycle. Lifecycle model management. Just what is the waterfall? A life cycle model? Life cycle of the program from its creation to its end. Let's see, what does... Okay, this I understand. So what else I need to ask us? So, this I don't understand. Let's see what ChatGPT has to say about this. See what this thing. I see, it's just... Well, I need to buy someone's calling me, so I'll just be back.
Oh, huh. Black tea for days. Let me, Agile development methods, forget. Oh, okay. No idea how much music do you get. Maybe if I make it a bit smaller, it's better thing.
Like, what is a Rambok? It's an outside method. So common elements of a life cycle. Steps and phases. Yep. Well defined. So life cycle. So what is a life cycle? Life cycle made out of? Well, it has decision points. So you have a step, phases, so steps, phases, output that produce an output, but how do I do a dependency? We have a roles. I mean, you can just like college row. Na 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 steps, step, phase. So you have a step and you have a phase. Na 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 na. That kitty cat. And then you have a dependency. Cut kitty cat kitty cat. Dependency. Dependency. I don't know, right? Dependency. Okay. So it's dependency. Let's call them dependencies. Let's put some red in there. Oh no. Sort of dependencies, and then you have their dependencies. Yeah, time, data order. Okay. Decision points, and this produces an output. Na 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 na. So you have all of these. So you have step, phases, output, dependencies, and you have decision point. Let's make it a bit bigger. And let's call this blue. It's a decision point. Entitlement, roles, common elements, lifecycle has roles. What are the roles of that lifecycle? These guys don't make any sense, do they? What are the roles in life cycle models? Project manager, sponsors, and then I can just I see you can just can I just no. 6. Responsibility approval. Okay, roles do the approval, blah blah blah. When it's ready to complete, that's satisfy original design requirements. Yeah, decision point. And then you have their dependencies and you have their phases. So when you think about it, this is a phase, you have dependencies, and each phase there is like someone who has a role to do that phase and so on. Someone does the testing, someone does implementation, someone does design, so it depends, right? So that's the point of it. So now the waterfall system development lifecycle processes, agreement process, organizational project name. This doesn't make any sense, they just put it here and then it's like so many things. Yes, you have system development, life cycle processes. So life cycle has then you have processes. What is a process in here? What are life cycle processes? What? Oh my god. What are life cycle processes? No. planning, system analysis, system design, implementation, testing. These are all processes. Ah yeah, things that you need to do. Those are processes, and you have different processes you need to do for each project. You have so many processes you really need to do. And these are the processes too. Phases and processes are the same. So steps and phases are the same as processes. Oh, there are distinctions. Okay, step, action, distinct phases, stages or segments, project phases, and a series of interrelated steps. I see. What is a process? What is a process in a life cycle model? In a life cycle model. Ta-na-na-na-na-na-na. So you have 1, 2, 3, 4, 5. What is a process and life cycle model? Well, it's several steps or phases that lead to a desirable outcome. Lead to an outcome. Desirable outcome. What does it say? Refer to interconnection of status conflict to achieve a particular goal. Okay. Lead to a particular goal. I can just define my own definitions here. No one cares. This is not math, is it? That's what the guys do. Like, they all define their own things, and they're like, desirable. I don't know how to strike desirable. No, come back. The waterfall model. Why do they have it black? Why do you put a black? When? And when? I hate when I do that. Like, do you really want to know when the first waterfall model was when the first life cycle model was created? In the 70s. Okay, 1997. Okay. Advantages: simpler, clear structure, well-defined flow of information. Disadvantages: handling. Changes are difficult, exactly. Winston, managing the development of large software system, proceeding of IWESCOM number 8. Oh my god, how long is IEEE for? When was this IEEE created? We move on. Disadvantages, advantages, yeah. The advantages are the simple, clear structure, because the structures are pretty clear. You know what you're doing, and every step you have like requirement specification, you have design, you have implementation, integration and testing, deployment, configuration, maintenance. Does it need the steps of each method? Understand the goals of software lifecycle models and their application? Yes, and define a basic like and just identify them, not have everyone. Yeah, because there's so many steps, right? To know all this, what's happened. Maintenance, deploy, integration, and testing. So you need to specify your requirements, and you design, you implement, you test for integration, your deployment, and then you have maintenance. Yeah. Case study from real life. Okay. A system, case study from a system is already operating. Some specific data should become what? Editable, consistency, integrity. These guys, they don't make any sense. So a system is already operating. So you have a system operating, some specific data should become editable. So you want to change some data and make it editable. Then how consistent that editable, integrity in the system. Oh my, preset. Should become preset, but editable for those who require this. Want to become preset, but editable for those who require it. Ask the man, the myth, the legend, because this guy's and them making sense for. Let's see what it does, because I don't know either what to ask her. Waterfall model. So if you make data editable, how consistent, how do you have integrity of the data if you change it? Reset, but editable for those who require this. And then you need the roles, who can do it, access management, and then editable for the external tools, and then how do you maintain external tool, about error connections and so on. Why they added this here, God knows, but I mean this thing, so let's move on. The cost of error, yeah, the more you go, the more the cost error is approximately exponential. So that the maintenance, if you keep error correcting, that costs so much. So if you design, it's so slow. If you catch it, implementation, you learn testing, maintenance, okay. Systematic measurements is a V-value. Iterative method. Okay, the cost of error correction. What is the cost of error corrections in waterfall model? More further, the more it costs. We don't care. Na 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 na. Ta na 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 na. Ta na 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 na. When do you need waterfall margin? Small one, already known. When you never need a waterfall model. Is waterfall model ever used? Already. When is waterfall used? Small project, known technology and already established. Why is there Russian in my ears? I don't know. And what does this guy say? I don't know, because I don't know this language. It's just a cool song, I guess. What is the solution? Yeah, systemic measurement. So at every step you measure, that's the problem, right? Model test, integration test, system test design, and so on. And then you do higher quality, predictability, yes, changing and backtracking, iterative methods. Changing and backtracking, iterative methods. Because they are iterative, yes. Because waterfall goes from ta-ta-ta and backtracking is iterative. This is the Weave models. Don't let the error get further. Dun, 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 dun. And then you have changing and backtracking. Changing and iterative methods. V model. Don't let iterative methods. And don't let the error get further, and you have iterative methods. And what do you do with iterative methods? Changing and backtracking. Okay, so backtrack, change, backtrack, change. Backtrack is agile. Backtrack. Good. And this is a flashcard. V model development of critical systems. Precedence. Developing critical systems. V models. What is V model used for? What is V model used for? Critical systems. One fast sometimes. What is a critical system? Yeah, it's safety critical systems are systems that do not need to fail no matter what. Human lives, blah blah blah. Error may have cultures of mission critical system, critical for existence of an organization, safety critical systems. Oh, so what are some types of what are some types of critical systems? Safety, mission, business, primary. So you have safety, you have mission, you have business, and so on. For normal. Ah. Didn't have guys on a certification process. Manif. The slides, last slides are the hardest ones. The other ones are like so much more understandable, and these ones are so much more abstract and doesn't make any sense. Start the manifesto for the child, what one?
Be back in 5 seconds.
Ta-dum! Hey, this nigga. Bum ba-dum bum 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 ba-dum bum. Manifesto 12 points. Okay. Goal satisfying the customer early in the continuous delivery. Yes. Welcome. Changing requirements. Frequent delivery. CI. Yeah. Nah. Oh, I got disconnected. Hello. Oh, am I streaming still? Let's see, yeah. Shit. Yeah, I'm here, I'm back and live. Oh, am I streaming still? Let's see, yeah. Shit. Yeah, it's good, good. Na, 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 na. It's also done, so let's go to the next one. I told you then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. Thank you, look.
Hi, good afternoon. My name is Brian Moberly. I work for Strategic Technology Consulting. I wanted to do this video for those of you who may be out there who are just getting into doing simulations with Cameo Systems Modeler using Cameo Simulation Toolkit. So this video is really geared toward the basics of simulations. There's a lot of good videos out there that Salius Pabaukas has on his NDSE execution channel that are great for all spectrums, whether that is basics or all the way through a lot of the more advanced types of simulations you can do. But this one is really to cover some of those basics for folks who may be just getting into using Cameo Systems Modeler and trying to do a simulation. So that's what this is for those of you who are just getting into this. So what I'd like to do is start by creating a block definition diagram and explain a little bit about what simulations are typically based around. Before we do that, however, there's a few setup things you may want to be aware of when you're getting into using Cameo Simulation Toolkit. And if you go to your resource plugin manager, you'll definitely want to have Cameo Simulation Toolkit installed. That is an absolute minimum, and then you'll need a license to use it as well. And if you need licenses, STC as a company can help you to get licenses for Cameo Systems Modeler or Cameo Simulation Toolkit as well, so we'd be happy to help if that's something that you're in need of. And if you notice, in my list of plugins, I actually do not have Cameo Simulation Toolkit as an option, and that's because it comes with the software package for the Enterprise Architecture Edition. So there are some different bundles of software. Some of those may include Simulation Toolkit, some of them may not. So for those of you who do not have that bundled, you can always come to your resource plugin manager and actually install that. After restarting Cameo, after you've installed your plugin, another really good thing to do is go up to your options, and this is specifically for version 2021X. If you go to Project, in version 19, you'd actually go to Environment, but in version 2021X, you can go to Project, and then go to Simulation. And if we look at the options that you have here, a few things that will definitely get you and mess up some of your simulations are some of these default settings. So I'd recommend setting initialize empty values to 0 to true, unless you're doing a lot with arrays. Then you may consider having that default to false, but I like having it set to true. Another thing that's good is to check model before execution. This can actually trigger the loading of a simulation profile as well, so that's good to have. There are some default languages, so if you're using things such as Python scripts in your opaque actions, you could
That's interesting.
JavaScript Nashorn says it will be deprecated in future releases, so you may be better off keeping that set to JavaScript and Rhino. So now let's jump into talking about some simulation basics. When it comes to simulation, really context is everything. And when I say that, I mean that anytime you run a simulation, it will have some context, or it should have some context. And what that allows the simulation to do is have access to the value properties of that context. So if we run a simulation and the context is this system block, it will have access to the value properties of that block, such as, let's say this is a system that has a value property of engine RPM. We'll type that as a real number, and that simply means that you can have decimal places. If you wanted to have no decimal places, you could use an integer. And there are multiple ways you can type these, so you can always use the T to type things and then change them there. So different ways to add the type for those. You always want to have a type. You need to have a type in order to actually use these in a simulation, so that's really good to know. So now that this system block is created and it has a value property, this system block has access to that value property if we were to run a simulation within that context. So how can we run a simulation in the context of that system? Well, you can right-click on that, you can go to run, and then it says the validation rules are not loaded. Would you like to load them? That is that triggering of that simulation profile. So notice now that we have this started, we have the value property down here that has been instantiated. Something also to be aware of is that this system block has been instantiated as well, and it's been given an object ID. So object IDs are very important, and they're something that are randomly generated, but they're good to be aware of because they will actually identify specific instances of different parts of your system. And it's just good to know if it does not have an object ID that it has not been instantiated. And there are times when you'll need to pay attention to that. So let's say we were to create a reference property instead of a value property, and we will call this max temp or max temperature, something like that, and then we'll type that as a real number. Let's rerun this simulation now. Say there's another execution in progress. Yes, let's rerun that. Notice there's no value for this max temperature, and it's because by default Cameo does not instantiate reference properties, but we can change that setting if we'd like, or we can simply come down here and add that manually, and then notice it now has an object ID. So that is great, and it's good to be aware of. So you could have known that by seeing that there were no values there, but now there actually is a value, and it has an object ID. Other simulation basics that are really, by default Cameo does not instantiate reference properties, and then we'll type that as a real number. Let's rerun this simulation now. Say there's another execution in progress. Yes, let's rerun that. Notice there's no value for this max temperature, and it's because by default Cameo does not instantiate reference properties, but we can change that setting if we'd like, or we can simply come down here and add that manually, and then notice it now has an object ID. So that is great, and it's good to be aware of. So you could have known that by seeing that there were no values there, but now there actually is a value, and it has an object ID. Other simulation basics that are really good to know is we can create things such as an activity diagram in the context of this system block, and then in that activity diagram, we will have access to these value properties that we could then manipulate with other types of actions, such as opaque actions. We'll create a SysML activity diagram, and then we'll use a simple loop. So a good thing to know about modeling loops is you always want to have that merge node. that we'll come back up to because you don't want to have multiple input control flows in a loop situation where you'd never have a token traverse one of those. So what I'll do now is use an opaque action, and these are really, really useful for simulations because you can enter in almost any type of software script and have that execute during the simulation at that specific point in time. And then keep in mind, we have access to the value properties of the block executing this activity, and currently that is that system block, so we have access to both that engine RPM value and that max temperature reference property. So let's say we wanted to simply output the engine RPM. We can simply write that into an opaque action, and now in runtime, Cameo will come through and get that value, and then we could output that to somewhere else. So you don't need to rename this output pin, but we can. And then what we could do with that is actually send that to some other opaque action, and maybe we're doing some calculations with that, or maybe we're sending that as a part of a signal. Let's say we wanted to send that as part of a signal, so we could create a signal in our model. It doesn't matter where that signal is created. That's more of a housekeeping item for you to figure out where you'd like your signals created. But we'll call this signal RPM data. And then what we'll do is we'll actually add an attribute to that that will carry the data of that RPM. So I'll name this engine RPM, and we'll type that as a real number because that is what it is currently typed as. And what we can do is drag that signal into this, and then we can actually take that value and input it into that signal. And then if we had other parts of our system, we could designate a proxy port out of this system to where that should go, and then another part of the system could receive that data. So after we send that signal, we'll just loop directly back up to this. And now we're ready to actually run a simulation. So when we go to run a simulation, what you can do is either run the simulation. So let's do that. And one thing you'll notice is that we do not have any instantiated value properties, and that's because I did not run this with context. So notice it also says that the reference engine RPM is not defined. And it's because it's looking for a value property that it can't find because we did not use the context of that block. So we will run this with context, and as of right now that is 0. We could change the runtime value down here to something else, and notice we now see that as runtime value. So that's running on a loop. So let's go ahead and add in a time event. We can drag that onto this control flow, and it asks you, do you want to put that before or after the control flow? So one thing that's good to know about that when you're dragging things onto a control flow is that really it's asking you whether or not that should be before or after the guard. So if you had a guard in a decision, then it's asking you, would you like this before that guard or after that guard? So for now, since we don't have a guard, we can actually just say before. It really doesn't matter. So notice this is at. Well, we could put it in at 2s, but at is an absolute time. So if you want to make that relative, we can go to our properties, scroll down to the bottom. Notice we're highlighting the time event. And then there's an option to change that to relative, and then it changes that to after 2 seconds. So now if we were to rerun this with context, what you'll notice is it'll get to that time event and just wait there for 2 seconds and then continue. So that's a nice way to use time events. Now, let's say we wanted to send that signal to another part of our system. Well, we need to have parts of our system in order to do that. So this gets into another very important concept, and that's dealing with parts of a system. So let's say that this is our engine, and then let's say this is our computer. And these are currently 2 parts of our system. So what we now have is one part property of this system that's called engine that's typed or defined by this engine block. And we have another part property or another part of our system that is called computer that's defined by or typed by this computer block. So if we were to simply run the simulation now, what you will notice is a few things have happened here. We've also instantiated 2 parts of our system. So if you look down here, we have the computer part property is now instantiated as well as the engine part property. So if I were to run that simulation from this engine block, you would only see the engine part of this running. And since there's nothing really associated with that, you don't see anything below that in the simulation variables pane. However, if you want to pull in all the parts of your system, you need to use that one level higher in order to do that. So I will use that system block, and then we'll instantiate, and we have object IDs now for those parts of our system. Notice that reference property still did not start up, and that's fine because we're not too concerned with the reference property at the moment. And
Weird though. Yep. Scum. Oh my god, this. Wow. I had to charge this thing. This screen is half dead too. Okay, let's go. Let's move on.
I'll actually delete that for simplicity's sake. So let's say this is our system. What's good to know about if you were to have multiple behaviors associated with these parts of your system is there's something that's called a classifier behavior. This is a very important term that is called classifier behavior. So if we look into the specification of this system block now, because we created that activity in the context of that system block, we now have an own behavior that is called system, because that is that activity that we created, but then is also the same activity as the classifier behavior. So the classifier behavior is the main behavior. It is the behavior that will begin when this part property is instantiated, or when this block is instantiated. So when we run this, that's why that starts up automatically, and you'll see that over here. So system, which is the name of that activity that we did not give a very good name to, has now started. And it's instantiated, and it's because it's a classifier behavior. If you were to go into the specification and unspecify that, which you can do and can be very useful to do in certain situations.
This is talking about things I have no idea about. No, there's something wrong. Like, I don't get this. Like, okay.
Hello there, Dermot O'Brien here from Spark Systems.
Oh my god, this is so weird.
Behavioral models into executable source code using Enterprise Architect's behavioral model code generation features. Using the behavioral models such as functions, sequence diagrams, and activity diagrams, Enterprise Architect can generate usable code in more popular code languages like C++, C#, and Java, as well as hardware description languages like VHDL, Verilog, and System C. There's also
This is so weird.
or even create templates for generating code for another code language. These features can be used in a variety of environments, ranging from high-end applications through to embedded code for automated machines, from simple devices through to components and complex units used in the automotive, maritime, and aerospace industries. Note that these features do require the unified or ultimate edition of Enterprise Architect. We'll start with an overview of a class with underlying behavioral models and then generate code from this in a number of different code languages. What we'll cover is a look at an example of the code generated, a look at the structure from the class down, generate out the code from the model, see the correspondence from elements to actual code for activity diagrams.
This is so weird.
Transitions, entry and exit, do actions, and sequence diagrams. We will then view the options available for different languages. And finally, we will look at customizing the generation using the code template language. The example diagrams that we'll be using to generate the code are available in the EA example model, which is supplied with Enterprise Architect. The particular diagrams we'll be looking at cover some fundamental functions used in the input-output of a portable audio player. The higher-end design is shown in the design package under the requirements package. For our purpose, we are focusing on the software language aspect, which is used for the implementation of this portable audio player. In this case, it is a generation to C++ of the USB interface as outlined in the design model. Note that there are also hardware language examples above this. To start off with, let's take an example of a set of classes under one language. In terms of the general structure, what is required is that the behavioral models are set under a class to basically emulate an operation. These behavioral models can be called in the same way that an operation can be called, and they can also call operations or other behavioral models. For example, a state in a state machine calling an activity diagram, or a composite diagram, an action calling an activity using a call operation. In this case, we explore a simple two-class model with a simple business one standard given operation, SIG number of bits received, as well as a much more complex behavioral model, including several activity diagrams. Here is one we'll look at: do read serial port. State machine diagrams. A key one that we'll look at is the search internal media, and sequence diagrams. This is a more complex one. We will run over a simple example later. Let's generate this class out to code to get an overall view of what is created. We select the class IO, open the develop ribbon, and in the source code section, we use the generate option. Now with the code generated, we access this via the class. By selecting the class and pressing F12 or Ctrl-E, we see the code in the code editor and its operation structure on the left pane and the actual generated code on the right pane. The standard class operation, set number of bytes received, has some simple script defined in the code properties which we see is generated out with the code. On looking at the behavior models under the class, we see the corresponding...
No, this is so weird. Like, what's the point of all this? Just code the thing. Don't just... This guy's checking. Help. Have a generation of test, I guess. Is this even working? Are you listening? Yes, it's been 5 hours already. Oh my god, generation of test cases. Generation of test cases. Yeah, it can generate test cases. It can help for formal methods. Get the point. Like, I don't even want to ask these questions, are so weird. What I want to ask is, this is the question, what do formal methods help? No, what do formal languages help with? Where are detailed models applied? Simulation, you can simulate. Simulation, analysis, to analyze the system, to generate the code, and to check for checking, formal checking. And then we have... okay. And this is the first question.
Hello everyone. I would like to introduce you to the results of a 3-year-long research called Pragmatic Verification and Validation of Industrial CSML Models. The motivation of this research was the OpenMBE community, that is an open model-based engineering environment which consists of a model repository, several
open model-based engineering environment, OpenMBE. Web services-based modeling and analysis. So they use these tools to create this thing.
And the analysis of systems engineering models, a view editor that lets users visit the models in the browser and also to leave some review comments there, and the OpenSC cookbook, which contains guidelines and best practices for modeling systems in the aerospace domain. Next to the OpenMBE community, there are several modeling and simulation tools that can be attached to this workflow. The modeling tools can help the users to design their system models, both the structural and behavioral aspects, and the simulation tools can help the users test the system in several scenarios. As we inspected this workflow, we identified that there is no element for the verification of the models, so to check that certain properties are met by the system and to make sure that the system is always behaving correctly. And also, there is a missing service for validation, which could check that the model conforms to certain structural constraints so that it can be verified later in the workflow. In the simulation and the modeling tools, we identified some semantic gaps between how the models are represented and how they are interpreted. More specifically,
Lack of systemic integrity.
both the simulation and the design tools conform to the UML and XML standards with several semantics, for example, the PSSM, PSCS, or the funnel standards, but these tools are not implementing the standards 100%, which means there are some differences between how the standard is prescribing certain structures, certain elements and their meanings, and how these modeling and simulation tools are interpreting these models. Due to these semantic gaps between the interpretations, the validation results that are written by the simulation tool might not be correctly represented in the modeling tool, or there might be be certain elements that cannot be checked because of these differences. To bridge these semantic gaps and to close the meaning of the model elements, we defined a model validation and verification workflow, which consists of a subset of SysML, and these validation allow users to check certain properties, reachability properties on the models to make sure that the systems are behaving correctly. Let's have a look at an example model. In this example model, we see a simplified system for spacecraft on the ground station. The spacecraft is sending packets to the ground station, and its battery is also depleting after a certain amount of time is passed. And if the battery is below 80, then it starts recharging until it is fully recharged. In the transmitting region, after the spacecraft starts operating, it sends data packets to the ground station. The ground station is receiving these data packets, it counts how many packets it has received, and it also forwards the received packages to the environment so that any other system that is listening on the outside in the environment can receive these packets that were sent by the spacecraft. To check the correctness of this model, we define reachability properties. Reachability properties prescribe certain state configuration whose reachability can be proved by model checkers. State configuration can consist of states of the state machine and also invariants of the blocks that contain these state machines. So in this example, we say that the spacecraft is in the transmitting state, its battery is less than 80, the ground station is in the receiving state, and it has received at least 20 packets. We want to prove that this state configuration is reachable. If this is the case, then it means that there is an error in the system, because in our case, this reachability property prescribes an errorless state configuration that shall never be reachable. If the model checker returns us a counterexample proving that this state configuration is reachable, then we can use this counterexample to check how the model is getting from the initial states to this errorless state configuration. And along this trace, we can see where the design went wrong, and we can figure out how to fix the problem. To support the evaluation of reachability properties, we define the following cloud-based workflow. Systems engineers are using their SysML tools to model the behavior and the structure of the systems. The system models are uploaded to LMS, the model repository. From the LMS, inquiry server is downloading the models and building an in-memory index on top of it. This in-memory index will be used for the analysis and the model transformations to efficiently execute the static checks and then to transform the models to a further representation. After the model is uploaded to the model repository, the user can open up a browser, visit the website to start interacting with the Jupyter Notebook. The Jupyter Notebook is our front end to the user. In this Jupyter Notebook, the user can select which model she wants to verify, and after that, she can check the structural correctness of the models by running these validation rules. The validation rules are run in the validation and transformation service, which receives the model from the inquiry server, as mentioned previously. It runs some static checks on the model to make sure that it is structurally correct, so that it can be used for model transformation. In the second transformation phase, we are transforming the SysML models to a so-called Gamma model. Gamma is a state chart validation and verification framework. It has its own language for composing state charts. Therefore, we transform the SysML state chart to this Gamma state chart. The reachability properties transform to Gamma property language model. And after the transformation is done, we are forwarding it to the model checker runtime. In the model checker runtime, the Gamma framework is transforming the Gamma models to the input formalism of the model checkers. In our case, we support HUPAL and Theta. HUPAL is good for verifying timed systems, so systems with time variables, and Theta is efficient for evaluating systems with many data variables. As I mentioned, Gamma is transforming the models to formal representations of the respective model checkers. The model checkers are evaluating the reachability property on the formal model. If the reachability property is satisfied, then the model checkers are returning a low-level trace, which explains how the model can get from the initial state configuration to the state configuration described by the reachability property. And it's transforming this low-level trace to a so-called Gamma execution. Transforming this Gamma execution trace to a SysML sequence diagram that we return to the user. The user can use the system diagram to run it in a simulation tool, and in the simulation tool, the user can simulate the diagram, or she can do manual inspection to check the states in each step. And
This is insane.
in the next moments, we will see a demo of this workflow. We will check this reachability property on the spacecraft and ground station model and see the resulting execution trace that is transformed to a SysML sequence diagram. We will inspect this sequence diagram in a simulation tool. Let's continue with the demo. What we see now is a Jupyter Notebook. In a Jupyter Notebook, the user can run Python code segments to interact with the validation and verification workflow. In the first step, we are looking into inquiry server. After that, we ask inquiry server to download the latest model revisions from the model repository. Then, select the model revision that we want to verify. We will use the spacecraft example. We ask inquiry server to index this model revision. We had already indexed this revision, that's why this operation was completed quickly. After that, we are logging into the validation and transformation service. To define the reachability property, we have three options in the browser. First one is to choose the reachability property from the model by sequence diagram. The second option is to use simple web form to define reachability property for just one SysML block. Or we can use composite form to define reachability properties for blocks with more than one state machines. Let's choose the sequence diagram for this example. To get the sequence diagrams from the model, the validation and transformation service downloads the index from the inquiry server to get the sequence diagrams from the model. After the download was done, we can select the sequence diagram code transmitting below 80. Then we are checking if the model is structurally correct. The validation results will be returned in a table. In the table, we can see that there are certain model elements whose meaning is different. So more specifically, we have two orthogonal regions who will be executed in a sequential order in the model checking phase. Moreover, we have two orthogonal regions who have variables which are read and written concurrently. And the user has to be aware that these conflicting read-write interactions might cause problems at runtime if the variables are written and read at the same time. If the user clicks on the element link, then the model will be opened in the inquiry model viewer. So in the inquiry model viewer, the user can inspect the structure of the model in a simple tree view and also see the properties of the model elements without having to install any SysML design tools on their machines. In this example, we can see that the operation region is an orthogonal region to the battery region, so the wordings were correct. Since there is no validation error in the model, we can continue with the model transformation. In the transformation phase, we are transforming the system state machines to gamma state charts. The transformation was successful. After that, in the model checking phase, we can choose between two model checkers, UPAL and Zeta. In our case, we will use UPAL because it is supported for timed systems. Zeta would be useful if we had many data variables. In our case, timing is more important, so we use the UPAL model checker. In the verification phase, we are transforming the gamma state machine to the model checker formal models, and also the reachability property is transformed to a formal expression that is evaluated by the model checker. If the model is satisfied, then we get the execution trace. The visualization of the gamma execution trace is presented. In this trace, we can see the initial state configuration, so the active states of the system, also the internal variables of each state machine and their values. In each step, we can see the incoming signals, the outgoing signals, and how much time was spent in that step. If we go through this trace, we can see in the end that the reachability property is satisfied, so that the spacecraft is in the transmitting state. It has sent.
They do so much work for. I mean, yeah, they're sending spacecrafts to. I mean, yeah, they're sending them to the moon, like, they're supposed to do that. I mean, good job. I just jammed like so many information. It's a formal verification, that's what the Self-Theta does. What are the what is required to define syntax and semantics? Rules? No. Yeah, the rules, the meaning. Syntax is the rules how to do it, and then what it means, and then you have a meaning for that, what it means. Yep, if I can. This is very weird. Can I set this up better? Ah, oh my god. Yeah, I'm setting this up better. I should charge my phone for this for much longer. Or I can just be clever and do this. This is weird. Where? Oh. Okay, nice. Nice. I need to. Oh, how is it now? Still. I mean, just deal with it. It's okay. It's just very weird, I guess. I mean, how does it look? 60 degrees. Oh my god, so I need to do this for it to be okay. But I can, maybe... Why does it do that, like... If I do this, then it's okay. Yeah, guess better. Okay, let's go. Okay, I had okay, too much information, but I get the point. So it's like formal verification, I think. And what do you need to model a language? You need the syntax and the semantics. Blah, blah, blah. Syntax is how to do it, and the semantics is what those things mean. Abstract syntax, concrete, well-formed rules, semantics. Okay. Defining a model language is abstract syntax. What? It's meta model, grammatical rules, okay. Well-formed rules, semantics. We move on, we put some music and we keep rolling. What is this song though? Na 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 na. Ah, banger. Defining a model languages, abstract syntax. What is, okay, we have abstract syntax and then we have concrete syntax. What is abstract syntax? Elements and a relation. What are the kinds of syntaxes? The kinds of syntaxes. Da na 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 na. Syntaxes for language models. For modeling. So elements plus relations. Meta model. Yeah, because, well, this is same thing because the relation is the grammatical rules, how they go together. This is a relation. This is a grammar. Elements, the relation, which is grammatical rules, and you have a meta model. No, I want. And I have a meta model. Because you need a meta model to define those things in the first place. Concrete syntax, well-formed rules. Okay, abstract syntax. And I put some picture and idea, but then concrete syntax. Abstract. Yes. Now just go on. It can be abstract and it can be concrete. And then the concrete is textual and graphical. How to represent them. Yeah, text. Same, is the same with that. For example, C++ has concepts, and how you implement those concepts is a different story. C++ is a programming language, right? So you can have, yeah, C++ is such a good example. Abstract. It's such a good C++ that has like visual functions and those things and what does those things mean and so on. And then you have a concrete ones, and the concrete ones that you can use different ones. And then you have a concrete things and you're like, yeah, then you have the, you can use different, yeah. You can use, oh, yeah. Different ones may exist, literally well-formed rules, and the rules can be well-formed, you have semantics and so on. This tells you what it is and how those things are related together, and then how you represent those relations and those things is such a different story. So this is abstract and concrete. Why do you need the well-formed rules? Yeah, the rules. The syntax has the rules. What is the difference with well-formed rules? Ah. Well. It's usually try to map to my. Semantic domain. What it does and what it... Declarative, it tells you what it means, it declares, it literally tells you this is this. But operational... And operational semantic tells you what it does, like what is... Okay. I'm so tired right now, but I need to keep going. How many hours in? We are 5 hours in. Metabolous model, yeah, metabol. And domain specific languages. So we have this chart, I know, I understand. What are stochastics? You search it quick on YouTube.
Hi everybody, Bill Polis from Profits Run. I want to talk to you about stochastics, which is a commonly used technical analysis indicator to help identify so-called overbought and oversold points in the markets.
You can have
Professor of Electrical and Computer Engineering in the Schulich School of Engineering, and this is Module 1, an Introduction to Probability and to Set Notation. So basically, the purpose of probability theory is to help us deal with uncertainty. And most of you, if you've got an engineering background in your undergraduate careers, will have taken at least one class on probability and statistics. But for the most part, your education will have concentrated on deterministic phenomenon. And when we say something is deterministic, it means that we can completely predict how it's going to behave. So for example, if we're dealing with kind of a classic sinusoid, that looks something like this. As long as we've got the equation for the sinusoid, we know its amplitude and its frequency and maybe its phase. We know exactly what that waveform is going to do at all points in time, so there's no uncertainty at all. However, there are... Hello, my name is Jeff Messier. I'm a professor of Electrical and Computer Engineering in the Schulich School of Engineering, and this is Module 9, Stochastic Processes. So similar to what we did with when we started our discussion of random variables, I want to begin our discussion of stochastic processes by establishing a very clear engineering-based notion of what exactly a stochastic process is. I guess, you know, the quick definition for a stochastic process is a random waveform. However, we can understand it a little bit more deeply by going back to our understanding of a random variable. If you'll recall, we came to understand that a random variable represents essentially a function that maps the outcome of a random experiment or a random process to a single number. A stochastic process is very simple. We can think of a stochastic process also as a function that maps the outcome of a random experiment to a time domain waveform. So rather than mapping our random experiment to a number, we map it to a waveform. And so when we write a stochastic process in functional form, it's a function not only of the outcome of our random experiment, zeta, but it's also a function of time. And so that's how we write our stochastic process. And so the best way to, get a more practical understanding of this is with an example. So I believe when we first discussed a continuous random variable, the example I gave you guys was...
it only randoms like in that side, but only it's random on time. I see. The stochastic. So it maps the output of a random experiment to a time domain waveform. So it also needs time.
The output of a noisy sensor, sampling the voltage at the output of a noisy sensor with a voltmeter, right? So in our first experiment, our random variable mapped the outcome of our experiment to a voltage value of 0.3. So we basically put our voltmeter...
I understand. Why does it call it stochastic process? It is stochastic, this thing, because it's changing over time. Probability changing over time. Quantitative stochastic, like over time what happens. So you have a model, you have a method model, and semantic domain. Oh. 13 done. Next one. But we keep going. I'll just take a small break. I'll download UML. UML behavioral models. PC go wild. Behavior model. What? Oh, you have it. too much to handle and go. So we have behavior modeling now. Yeah, this is a lot. This is not easy. And the stream has been going for like 6 hours. I'll be just back in like 20 minutes. I'm a bit tired. I'll rest for a bit. I'm back. So let me put some music in just. Na 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 na. I don't know the songs. Pum pum pum. Behavior diagrams. It's called control flow because where is the control of a thing? Which one has the control of to be executed? And then it has state based and you have data flow models. Yes. There is a difference between state machines and activity diagrams, because the state machine diagram is it models the state of the machine. You have a state the machine is in, and it sees when something user does something, what does the state changes. But the behavioral models, it models what kind of behaviors can happen, and those behaviors have many use, and in those behaviors users can do many things. Can search files, for example. Searching files is a behavior, but the searching itself can be modeled by a state machine if you want to. But the point is that it models behaviors, it models actions, I mean. Not behaviors, models action. Activity diagram models actions, and state machine model states. It doesn't necessarily mean that the state changes, or like state changes many times. It's not related. I mean, it's a bit related, but not really in a sense. Oh my god, this is actually kind of tiring. It's like, okay, let's go. So UML behavioral models, representation of one or more possible traces. Sequence diagram, yes. Traces. Did I hear traces somewhere? Representation of one or more possible traces. So you have a trace, something happened. Simple trace. Timing diagrams is for timing. Yeah, these are interactions. So interaction diagrams. So you have use case, this describes the use cases, and then you have interaction diagrams. How do you interact with the system? Just find the use case. When can you use the system? Describe a state machine, tell you how the state change, activity, and what kind of activities can you have. They're kind of similar use case diagram. You can convert them to interaction diagrams, but not really. Common behavior elements. So you have an action executes, you have an occurrence, sends a message, and then you have an event pool and it triggers a behavior. Like this to me makes no sense at all, but okay. What are traces in UML? What are traces in UML? So go on like a fight. Tan 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 tan. A general purpose relationship between two items. Event pool trigger. Done. Activity is a process, but take. Bro. You want me to watch me struggle learning this thing? This guy's like have like, I don't know, so many slides and things to learn for the exam. Hello, old friend. Oh my god. You made my day, bro. Bro, you just made it. Hey, yeah, I'm dying here. Like, look at this. I have all this slides, all this material. I'm just here. And the test is like 3 or 4 days. And the test is like 2.5 hours or more for an exam. Like, these guys are, what are these guys doing? Like, look, exam information. First part, how much hours? 2 to 2.5 hours. Oh my god. It's 2.5 hours test just for a simple exam of these guys. And this is like the easy part. Wait till I get the probability theory. Like I have, oh my god. Oh, you're learning graph theory? Oh, that's cool, bro. Graph theory. We learned it the previous semester. Can I please chat? You're learning graph. You're learning what a graph is. You're learning matchings, algorithms, Bellman-Ford algorithms. You're learning flows, and minimum cut, like maximum minimum cut. You're learning Boolean. I learned it the first semester, Boolean algebra, and the second semester I learned graph theory. And so, oh, we learned so much. Boolean algebra. You wanna see my graph theory? Like, you don't. Here is like the. I learned a lot of graph theories because like here is like the where the graph theory started. Look at this graph. Bro, you made my fucking day. You see what I bought? I bought this. I didn't buy this watch. I won this watch in a programming competition. Like, I was at the competitive programming and I saw those dudes programming like I don't get it anymore. And now watch me struggle here because I need to learn, bro. Like, I need to speed run this. So I'm taking flashcards and I have so many flashcards made here. What is a process and what is an activity? Blah 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 blah. Well, a process is just like let me draw it real quick. You have input, and then you have so what is a, so first you need to answer what an activity is. Activity. Actually, it's pretty good. I won it. It's so cool because I won it at the competition. It's like I'm like doing a lot of like competitive programming. Like, to me, graph theory, I do it every day. If you like that, you like my stream? You like my stream? Bro, I'm dying. I've been streaming for like 6 hours studying already, and I'm like dead as fuck. Okay, what is a process and what is an activity? What is an activity? Like, they don't even tell you what an activity is exactly, and you're like, what is this language? What is an activity in UML? Oh my god, I'm lagging. Seems that there might, yeah, UML. I mean, yeah, blah 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 blah. Definition: activity. An activity is a type of UML diagram with diagram? An activity diagram, yeah, but what is an activity? An action, what is an action, I mean? Or no, an activity. Legit, this is legit. Bro, my only viewer, let's go. I got one viewer. Until Monday I got so many views, I was like, why are these people? When I learned databases, I got so many views for some reason. An activity diagram. What is an activity? Like, hey Google, what is an activity? It's in UML. Not an activity diagram. Wow, oh my god, what is an activity in UML? I'm gonna break this thing. Is a major task that must take place in order to fulfill an operation contract. These guys, like, look at this definition, like, just an activity in UML is a major task. Like, why do you want to call it a major task that must take place in order to fulfill an operational contract? Bro, fulfill an operation. What is an operation contract? Never ask. This UML guys don't make, like, this UML graphs don't make any sense. I love when we have maths though. Let me send you a heart. Let's go. And activities do something, I guess. A process is you have input, and then you have many activities, and then you have output. Easy. This is how easy it is to define it yourself. These guys just made it so hard. Dun, dun, dun. I'm just so mad. Input. See ya, bro. If you're still here, see ya, bro. If you're not here, see ya, bro, again. See you when I come back to Pristina, I guess. It's gonna be so cool. Description: all established in different versions. Control structures of program, brainstorming, flowcharts, scheduling project tasks, yeah. Okay, I don't care. No one cares. Common elementary steps, the dependencies among them. Yes, you have dependencies among elementary steps. How they can be used in software system. High level description of business system. Yeah, additional behavior. At high level you describe system processes, and low level you describe behavior. Oh my god. 21, 20, no, 24. I finished the test on 21 and I have tests again on like 7. Fight down. Christina town. On 24 I think. We meet, bro. Diagram. Diagram. I love it. Diagram. Look at this graph. Dun, 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 dun. I love, bro, you made my day. You know you made my day. Oh my god. Description of business system. I need to learn this though because I don't have a lot of time to speed run. How they can be used in software. Okay, high level and low level. High level, I don't know. Low level. But what would they ask here? Like, how they can be used in software systems? I'm like, okay, high level, low level. Like, what? Why? Why do you make this separation? Like, it just doesn't make any sense what they do. Elementary operations on UML elements. Oh, actions. Oh, activity versus actions. Well, activity is many actions, I guess, so. Elementary operations in UML elements. So this action is like the base. Da-na-na-na-na. Effects of an event. Detailed behavior in an executable model. What? And what is a behavior then? Many actions put together? Peppa the Frog Lord. Peppa the Frog. UML activities. So first you had process models and then you have UML activities. How they can be used in system software just systems, and I'm like, they, what they, who is they? The program, the process models, process models, and how they can be used in software systems. Like, these guys don't make any sense. Oh my god. UML activities, basic elements, steps, nodes, and flow edges between them. Okay, nice. Elements of activities. Okay, good question. What are the elements? Oh my god, of activities. I mean, basic elements. You have nodes. Ah, this is the context. This is like the context, and the abstract is steps, and the context is nodes. And you have a flow, which are edges, and edges like is the context. It's like, and this is like flow is abstract. I see. So you have nodes and edges, you have dependencies, you have two types of dependency, control dependency and data dependency. Okay. Elements of control, this is good part actually. So you have elementary activity. So you have activity. And what else do I want to know? I want to know what do these guys, exam information, UML. So we have exam information and it says want to write an email to them. Or a screen. No. Can I, yes. UML syntax summary will be provided. Yes, and I need that UML syntax summary. Give me the UML syntax summary. Do you have solutions for UML expresses? Okay, where do I have a UML syntax summary? Nowhere to be found. Let's go. Then I need to write to these guys. Let me... What should I open to write to them? Gmail. Well, my professors, I cannot even find their names in here, so this is very good. So we go to Teams. This song is such a banger. Okay, I need to write to them. General. Someone wrote me to chat. What is written to me? What is the difference between operation and method? Dun, dun. I had an activity somewhere. Got it. Now I need to write to them in general. Can I? Done. UML behavior models, my friend. Too many things happen at the same time. Here. Where are you? Oh no, Buck is here. Oh, Lamau. Bros are here. Oh. All the bros are here. Lamau, rip, guys. Look at the exams. Oh, Buck is here. Okay, I need to learn. Okay, just the elementary activity, I guess. Activity, initial node, final node, easy. Hi, Bucky. Hi, Buck. You're Buck. To me, you're the Kosovo Army editor, not gonna lie. No. Dying. I'm dead. How are you? Dead inside. Yeah, nice. I'm surviving in another country, I guess. But we move on. Yeah, how are you though? How have you been? Yeah, I'm a Firefox user, bro. I'm a Firefox user. Look at this. I am based. I use Firefox. Yeah. I don't know. I like Firefox more. I won't die, I'm surviving. I have two exams and then the other half after the Christmas, after Christmas I have 2 more exams. Yes, we meet. When I go to Pristina, we meet again. First, I just need to finish this, so I need to speed run. But thanks for being here. Thank you. Well, it's kicking my ass. I guess we're all like, yeah, it's all the same everywhere in the world. Turn to the initial and final, yeah. Good luck, is you too. Good luck. I mean, banger songs, not gonna lie. Easy decision and merge. So this is easy because you do like, you come here and you make a decision, and this is the other decision, and then this is the merge, and you always have a decision and about dying. Now we're alive, I'm living, I'm surviving. No way I'm dying. I ain't dying. You know how I feel? Let me explain. This is how I feel. Yeah. Sing my room and I. This is how I feel. Let me put on the complete. What is the complete? This one. I love this one. You in the leaves, this so far. Let me put me. Good luck, bro. Good luck. And then yes, in the front. Thank you. Heart. Cause you tell me to the passing by. You're using my home and I. Oh my god, this song, bro. So you have modeling loops and decisions, you have a loop and you have a decision, you have a merge, you have another decision, but this decision has a merge in here, but it is a loop because it goes the other way. So you have this way and the other way. But it is a weird decision though. It's like a do. This is a do while loop. Because you first do it and then here you check, afterwards you check and then you go back. This is like yeah, this is a do while loop. Banger. Do I have this one? Do I have this one here? All these songs are gonna be so nice when we come down here because the last ones are so nice. I'm just waiting. Parallel execution, fork and join. You have modified, compile, easy, right? Easy. Then we have parallel execution. We have a fork and a join. So I can say what are the elements? What are the of control flow model? Oh, this is control flow model. And you have activity diagram for a control flow model. Yeah, it's a control flow model because it has a control. No. What? No, this is not an activity diagram. You have a data flow model now. Elements of a data flow model. Oh, we have, because UML activity has like control model, has data flow, and also it has control flow. I see. I got the music. Oh, I got the music now. I see. This is a fork, so we have of control flow diagrams, and then here you type the thing. So you have activity, an activity. So and then you have initial, shell, and you have final nodes, and then you have fork and join. You have a control flow. You have a flow, the arrows. This is the flow. Initial, yeah. I love the songs right here. Control flow and decision and merge. You have decision and merge. So you have decision and merge. Yeah, because you have a decision and you have a merge, and then you have loops, which create loops. Nice. And then you have fork and join. Fork and join. This is parallelism. No. What is the symbol of invoking another? What is the Not is the symbol of invoking. I don't know how to write this word. Invoking another activity in UML. This call activity action for user authenticity activity. Call behavior action. Call activity action indicates that by a rare take symbol within the action symbol, not the through UML. Specific provides instance there is no call activity action UML specification. So this calls another activity. This is a call another activity. This calls another activity. Okay, nice. Oh, they copied it from here. Those guys. They just copied it from here. Nice. Oh, I don't have an account. Nice, bro. Jim knows what he's saying. Da da na 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 na. Na 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 na. Oh fuck. Easy. Na 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 na. You have a flow and so this weight wait for all to finish. I lost just the initial node, decision node, fork node, join node, merge nodes, activate in final node. Final node, initial node, fork, join, merge. Okay, nice. Coffee machine. Let's do this exercise real quick. So we're doing the coffee machine. So let me take my tablet. Let's do this. I mean, how much battery does my phone have right now? Let's see everybody. Phone. Hello. So I'm gonna have an activity diagram. So you have UML, some nodes. Screen. Ha! So I need to draw this thing. So how do I fucking draw this thing? Let's see. Dun, 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 dun. Well, if I can just draw it this first place, nice. So let's fill left reservoir with cold water. Okay, so we have fill. So there's a fill state. Fill. Activity, this is a fill activity. Place cup or mug on left side of a unit base. So we need to place, and we can do place cup or mug on left side of unit. Place mug, and then you have place a pod. What is a pod in here? I have no idea. In the left side of the brew bag. Well, you can do all of this at the same time. Or can you place a pod and fill the water? Yeah, you can do that. Place pod. Place pod. And you can have plug in unit and press. You can't plug in at the same time. You can do all of these, right? You have a starting phase and you have this. You have all of these going, all of these like this, because you can do all of them one after the other. And then this, all of them merge. All of them merge together. And then here you have follow both left and right instructions to make 2 cups at a time. Then you have left and right. And then you can have start, stop, and you can have do you have arrows? Yeah, you have arrows. But you can. Okay, you can do a fork in here, and you can have are 2 initial nodes allowed in UML diagrams? Are 2 initial nodes allowed in UML diagrams? Not really, you can just do a fork because they can run in parallel, right? So each one of them can have in parallel if you want to, one option. You can make all of them to have right and left options for all of them. This is one option. I mean, yeah, this is one of the options. And then the other option is you make each one of them a fork like this. Da 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 na 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 na. And then you have 1, 2, and you have left. You have this too. Na 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 na. And then you have you have left, you have right. Nice, we move on. And then we have elements of a data flow model. Oh my god, my table right now is so messy. So we move on. Modeling data flow. Activities usually produce and consume data. Data is broader sense. Data in a broader sense. Object, instance, material, item. The produced data may be the input of another activity. Modeling a data flow. Activities usually produce and consume data. Data in a broader sense. Object, instance, material, item. So you have a data flow models. Yeah, but you have pins in here, right? Yeah. It may go into a controller node. So input output pin. Is data represented in UML? Object node. You have an object node. Data connected to actions, you need an input and output pins. Parameters? My activity with parameters activity. is an act and it takes an activity in. So it's my activity with parameters. Parameters on activity. Act. Parameters of an activity. So you have the parameters of an activity. An activity can only be connected to a pin. To input pin. So input pin to input pin, and you have object. Input pin to fork. How do you distribute data objects? How do you distribute data objects? How do you distribute them? Which one is competing, a competition, and which one shared? First one. One is a competition. Is sharing. So I have counterflow and data flow. When can you remove a control? Simplified representation of a data flow. This is an object node? Yeah, this is an object node. This is important. Activity partitions. Why did they partition this? It's what? Swimlane. And we need no. The semantics now. That was the syntax, and now I have a semantics. Offer and receive tokens. Okay, so I have a process order. You have a process order, and here it comes a process. Here is a token, the control flow token. Here I have a data token. So it receives both the tokens it needs, and after it receives them, that requested order. Object node, and you have connected to receive. So it's pin to pin and object node to action. All these songs are bangers. So you have receive an order and you get the blue thing, and then illustrate the execution tokens. Yeah, you get the blue thing. Because it eats up, it uses the requested orders and it gives operational note. And then the token goes here, that's all it needs. Then it produces 2 tokens, and this get it, and this goes here. Oh, it goes here and it waits for this, and this is a data token. So it takes the control token and it does the data token, and then this waits for a data token, and then this returns a flow token, right? And this gets a flow token. and then it moves on. Nothing interesting, and then it ends. Advices for modeling activities. Is the following model correct? So is the following model correct? So you get it, never merge the decision, so if you go this way, you're also waiting for this way, but you never are, so it's a deadlock. Decimerge. You have a decimerge join fork. So decision. This is a do while. Oh, these bangers, bro. Other. Because I can. So this has, I think that's also reactivated. Yeah. Yes. I need to write to my professors. How many hours are we in? We're 7 hours in, let's go! We're losing our minds slowly. I love it, I love it, I love it, baby. Let's go. We have UML state machines. Interaction diagrams. Let's do, and then we have easy, I think. Oh. Confirm. Na 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 na. Ah, nice. State machines. Let's go. And for here we have state machines. What is a behavior in UML? So what is a state? A state has different behavior in different, so each state has some different behaviors. So you can have an activity diagram for each state. No, it's not activities, no, it's just a behavior, it's different behaviors in each. React. I love final state machines. We have not done protocols. States and transitions. Oh, the table. Finally, I have a definition of a trace. Or do I use trace here? I don't know. It's fine, this is how they define traces. A set of possible traces. Traces, series of input and output steps. So input you have an event, output you have egg. All the possible steps you can take. So this is all the possible. You can do E, F, E. You can do E. You can do E, F. You can do E, F, F. You can do E, E, E. So what are traces? So what are traces? All the possible steps. No, 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 no. What are traces? All the possible steps. What is a trace? What is so it changes activity diagrams, changes changes. Aha, so when you change, also when it's saying a state machine, it changes. When it says here a state machine, what I'm saying, when it says here different behavior in different state, it means it has different kind of traces, a different kind of the sequences, a series, different kind of series. So you have a series. Yeah, it's very good to find a series of input and output steps. Nice, finally they defined it how you should define it. Very nice, very nice. Traces. For all. Set of all traces. Of all traces. So you can input this, you get this output. Why is this? It's behavior. It's written right. Behavior. Control P, Anki. No. Look at this. These questions. together over 100 questions. How they can be used in software systems. High level, low level, everything. Specification of a complex class. So you have a state, it's invariant. State doesn't change. What? How is the transition item? Transition. So how is it written? Well, you have a pseudo state. No, you have a trigger, the event. You have a trigger, you have a guards. And then you have the effect that it has an effect. Yep. You have a transition. Refinement of state. Simple state has no substate. Composite state has at least one region. State and pseudo state. Between state and pseudo state. Simple state has no substates. Composite state has at least one region, which is equal container for nodes and transitions. No. State and transition. Refinement of states. We have a simple state and you have a composite state. Okay, what are we doing? Big question. Ta na 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 dun 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 dun. Oh, my brain is dying slowly. I think state and transition. You have a state, implicit invariant holds it. You have a pseudo state, transient state, silly. Yes. Refinement of state. The simple state has no substates. Okay. As one region? A simple state has no substates and a common submachine. Because it contains simple states and composite states. This is a submachine. They call it a submachine refinement. So you have a simple state, it has no subset, you have a composite state, it has at least one region, equal container for nodes and transition. So yes, what is a region? And then you have what is a region? What is a region? Region. Container for nodes and transitions. No. Oopsie. What is a region? What kind of states? What kind of refinements? Refinements of states. State, pseudo state, simple state, composite state. States state. And you have a simple state. And you have pseudo state. Simple state. Simple state, composite state. And then you have submachine refinement. Submachine refinement. Dun dun dun. No 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 no. And you have OR type and N type. Ah.
так уродливы?
Скорее наоборот.
Сомневаюсь. Сейчас бы не отказался.
А я вот виски хочу.
Шотландский?
Вон,
Деревенщина.
именно. Обожаю кент.
Na 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 na. Show. So let's see what we have here. How would I explain this graph? How would I explain this graph? So you have a big graph. You have a big graph. And then you have on. So in the test I will draw this. And I have, oh no, yeah, I got it. Ore refinement. This big one is ore refinement because you have this one, you have either this one or the other one. We're gonna buy. And then this is and the refinement because you have the state on, you have a state on, or you have a state off, and then it starts here. Well, haha, you don't put it like that. Because this state starts there at off state. And then the off state can say off, or it can say on. It can say on to the state. This can say out. It disconnected. You have standby. Standby. You have out. In. You have standby disconnect, you go out in, and this isn't on. This goes on, and let's say out. What? Yeah, this is an or because either this or this. And you can even have sound on, so you have sound or image, and you have an image, you can show, look, there's a show, and you have clock or no clock. From this state you can say I need a clock, and then no clock. You can start with clock, and move to this coordinates, and show coordinates. Sound off, yeah. Active state configuration, because not configuration, active state configuration, because you have a state, that's a possible state. Yeah, that state, that specific state is active, and you only have one state. Off, standby.
I'm here.
I'm not tired at all. Let's go, baby. No tiring here. We only finish things. I see. What? 7, 8. I think I've done more than half. I just need to eat right now. I need to cook. So what do I cook? So what do I cook when I have nothing? I got nothing. Well, I will eat some cornflakes. I'll eat some of these. Oh, but I have it already. Yeah. I'm just making. I'm just making like milk with cornflakes. I don't know. That's not even cornflakes. It's like some Russian thing. What is this? What? What the hell? It is what it is. I don't know what music is there right now. What is that? No, it looks so weird. I don't like this one. I like what our host is 3 too. Ah, 144 hertz. Oh, we need to do the coffee machine.
Oh my god. It's 8 hours. We're gonna get till we get 12 hours. 4 more hours is too much, I think. Minecraft is so boring.
Math is, no, if you compare the math and the games, like if you compare the math is like the queen, because like, when you think about math, you have so many things, like so, the level of abstraction and beauty of math is insane. But I'm loving this, bro. This food, I love it.
Oh my god. I like all red sauce.
Imagine starting with this music. Gotowe wody. Banger. Oh my god. Where are we? Which songs are we at? So I have... Oh my god, I have so much more songs. And we only are at 122. How much hours is this completely? 9 hours and 30 minutes. A complete. This is like a complete fight. This is so nice, like. Da da na 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 na. Best playlist ever, I'm not gonna lie. How are we holding? No idea, I'm literally dying. Me and my 1000, I'm joking. Too many years. I'm fine, college kicking my ass. Should have a coffee machine.
Those times only smokes.
Wait, let me measure something. No, I haven't. This part is such a weird part, I have it here. Oh, bangers. Oh my god, it's so good. No, 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 no. YouTube is probably dying. It's like 8 hours and 30 minutes. Nah. I mean, I just need to remove this video after all, right? How is this even alive? Like, da na 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 dun 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 dun. Oh my god. This songs, this guy has this songs, it's just like dun 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 na 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 na. I love that. I don't know, let me see. Dun dun no 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 no. So yeah, this is his banger. This is such a banger. Look at this. Funk. Should I see what's new at Funk? Na 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 na. I wanna see what's new at Funk. Funk. Let's see, baby, what is new? Ah, this is the first one. I have this one. This is like real. Yeah, I didn't like this one. Okay, so I don't like Brazilian funk. I don't like this one though. I don't like this one. So look at the difference. Look at the fucking difference. This is insane. I don't like Brazilian funk. Na 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 banger. I sounds weird, but I like it though. Brazilian phone. Rave. Shout. Yum yum. Yeah, the girl dancing. Is that little girl dancing out? What's my name? Millimeter go gang. Banana wang. Banana dang. This is such a bad song. Yeah, this song is just insanely bad. I don't like this. Is like so like look at like different. I don't like this either. I love the old phone. No, bro. Like look at this one. This is good phone, bro. Like a na 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 na. I mean they're all good, but you get my point. Banger. You see, it's such a banger. It's such like it's so good. This Brazilian funk is like so weird and generic. And just look at it. See, such a banger. And then you have like this one. This one is something about this one. It's just like feels good. And this is also very good. Sea of Problems. I have them all. Which one? I don't have this one. What the fuck? Banger. How don't I have this? No. Oh my god. Why don't I have this? Like I only Brazilian funk. So this looks like Brazilian funk. What? No. It's bad one, you can see it. Oh, but it's by this guy. No, this is gonna be good, I think. But this is Brazilian funk. I don't like it. Yeah, Brazilian funk. Oh, this sounds good. Nah, this sounds good. And it's Brazilian funk. Why do you need to add the... It just sounded so good. What do you mean? Oh, look at this. Look at the real funk. I'm joking. No. Like it's so lovely. No. Like it's like hard but like lovely at the same time. Like you can just play the same notes of a violin, it would sound so sad, but like because it's like sad, but the instruments are hard, it just sounds. Na, 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 na. I don't like this. Bad. What is this? Who put this here? Sounds interesting though. What is happening? What is this picture? What is this? Oh my god, this sounds weirdly nice. Brazilian folk. But why should you? I don't like those drums, sorry. How don't I have override? No, 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 no. How don't I have override? Nah, this is. Na 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 na. This is actually good. This is like a good one, I think. It's Brazilian funk, but it doesn't have those voices. Like it doesn't have those weird like shout. I don't like those. Okay. And then it's bad here. I don't like this part. I don't like their singing. Sorry. I like this song though. Hey, this sounds good, not gonna lie. And then it's broken because it's like funk at the end. Psycho Crows is also good. Yes, yes, yes. Make it here, bros. You make it to my playlist. Let's go, bros. Good job. And then, I use this Brazilian phone. No. Oh, this is good. Bum bum bum. Da na 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 dun 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 da na 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 na. Banger. This is Brazilian phone. It sounds good, but why do you put those Brazilian things? Like this sounds so good. It sounds like something I would make. The mixing is bad, but it doesn't matter. And this is studying, guys. Literally, this is how I study, right? I'm just eating right now. I hope no one just joins in and sees me listen to music. I have this one. Only one day, he smokes. This also, but this sounded good though. Very good music maker, man. Average FS20. Enjoy. No, I like this guy. Funk Brazilian funk producer guy. Very good music maker. Nah, this man made me laugh. Very good music maker. Let me send it to one of my friends. Crown. Send it to my... This... Oh my god, I don't have more RAM. I should buy more RAM. Made me laugh. I should buy more RAM. What is this? No one cares. Nice. Where is this? I don't know. Suicideer, good. Funkstar, good. I don't know, listen to this. Oh. Oh, wait, this may sound good. It's good. No. It is good. Let me hear it all. It is good, it's not very bad. I need some to clean my desk. I don't like it. Don't like it though. Nah, I don't like it. I don't like. I don't like this. Oh yes. Dun, 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 dun. Na 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 na. You see, it sounds sad. It's sad. If you play this on violin, it would be sad, but because the instruments are good, it makes it so strong, and it sounds so good. Like I don't know, I like this kind of thing. Na 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 na. No, no, no. Na 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 na. You see, it's like sad, but it's good. Not like this. It just sounds it sounds like you have mental problems. Sounds like it's mental problems. This ain't beautiful. This is mental problems. Move. What? I don't know what this is. Oh, this is good. Smoke it off. Lumi, I like this guy. Lumi Athena. Please, baby, please. Baby, come on. Oh, we do another one. We press this. Well, I think we need to do a which I hate. Not bonkers. Please, lower. Okay, till you render, I have because my PC is dying from all this recording, I guess. Da na 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 na. Ask my sister. Bro, why is Spotify so yeah. Barcelona.
headache.
Okay, everybody, welcome back to. I need to clean my room. This milk was so good. I feel so happy.